Okay, one more minute.
Allie, you're on mute.
Thank you, Dr. Gentry. Good morning, everybody. My name is Ali Munir, and I am serving as a designated federal official to the U.S. Science Advisory Committee on Chemicals, SACC. For this meeting and in my role, I will be opening the second day of the public meeting on EPA's 2026 draft hazard and exposure assessments for 4,4,1-methylethylene bis 2,6 dibromophenol, or TBBPA, 1-dichloropropane, 1,1,2-trichloroethane, trans-1,2-dichloroethylene, and ethylene dibromide. I'd like to repeat that the SACC meetings are subject to all FACA requirements. These include open meetings, timely public notice of meetings, and document availability to the public. All documents are available to the public in the docket at regulations.gov. See the docket number in the meeting agenda. Also, this meeting is being webcasted, transcribed, and recorded. A live stream of today's meeting is available on YouTube. See the link on the meeting website. The website is listed in the agenda, which also has a link to yesterday's meeting. We had a successful opening day yesterday, and I would like to thank the SACC and the ad hoc peer reviewers and the EPA team for their presentations, and the public also for their public comments, and all the discussions that we had yesterday. And now I'll hand it over to the chair, Dr. Robin Ann Gentry. Dr. Gentry?
Thank you, Allie, and welcome back, everyone, to our second day of meetings. We had a robust discussion and very nice presentations from EPA yesterday. And before we move into today's charge questions and discussions, I'd like to do a quick roll call and start with my co-chair, Miss Allison Jenkins.
Good morning. I'm here.
Right. Dr. Baker.
Good morning. I'm here.
Thank you. Dr. Barranco.
Good morning, I'm present.
All right. Dr. Burgoon.
Hey now, I'm here.
Good, thank you. Dr. Chen.
I'm here. Thank you.
Thank you. Dr. Dorson.
Top of the day to everybody.
Thank you. Dr. Ike.
Good morning, I'm here.
All right, thank you. Dr. Fong.
Hi, good morning, I'm here.
Thank you. Mr. Garvey.
Good morning, I'm here.
Thank you. Dr. Lee.
Good morning, I'm here.
Thank you. Dr. Ryer Powder.
I'm here, thank you.
Thank you. Dr. Stommel.
Yes, present. Good morning.
Dr. Shin.
I'm here. Good morning.
Good morning. Dr. Tonsel.
Present. Good morning.
Good morning. Dr. Thompson.
Good morning. Here.
Good morning. Mr. Wright.
Good morning. I'm here.
All right. Dr. Haber.
Good morning. I'm here.
Good morning. Dr. Klonig.
Present.
All right. Dr. Osmond.
Present.
Okay, and Dr. Niemeyer.
Good morning, I'm here.
Okay. So we're going to move things around a little bit and move on to our next charge question. As I mentioned yesterday, we'll have the full introduction to the charge question on the screen and also available in the meeting agenda in the public document. And once that's up, we'll take a moment to read that, and then I'll have the EPA read the charge for question 3A into the record. I'll turn it over to EPA to display that.
I'm sorry, Dr. Gentry. Hi, this is Kathy Denisio, Science Advisor, EPA. Can I ask one question first?
Sure.
And I think this is what you were referring to before, but just to clarify that we will read in the responses to the clarifying questions after the deliberations on this charge question. Is that what you were referring to?
That's correct.
Great.
We're going to cover charge question 3, and then we'll turn back to the EPA for responses from questions yesterday.
Wonderful. And then one other follow-up question is if you can let us know when you have a sense for when we are going to revisit charge question 1, that would be helpful just for our planning. So whenever you all have a sense of that, that'd be great to know.
Okay. I'll let Allie know and she can let you know, but it will probably be later in the week.
Okay, great. Thank you so much. Appreciate it.
Thank you. Okay. I guess we'll move on to reading 3A into the record.
In section 2.3.2.
Wait a minute, Dr. Ryerpower. I'm sorry. EPA will read that charge question into the record. That's fine. That's fine. I was not clear. Looks like Dr. Orentis is going to read that in for us.
Yes, next slide, please. Please comment on the strengths and characterization of uncertainties relevant to the Kirk et al. 1995 study and the selected endpoints for acute oral, inhalation, and dermal PODs for 1,2-dichloropropane.
Okay, now I'll turn it over to our lead discussant, Dr. Ryerpower.
Thank you. So charge question 3 concerning 1,2-dichloropropane focuses on non-cancer PODs for the acute, intermediate, chronic oral, inhalation, and dermal scenarios, root-to-root extrapolation, and short-term to chronic extrapolation. Question 3A requests comments on the strengths and uncertainties of the Kirk et al. Study and the selected endpoints for acute oral inhalation and dermal PODs for the 1,2-dichloropropane. Question 3AI requests comments. We are doing 3AI right now too. Is that true?
That's correct.
Okay. Question 3AI requests comments on the strength and uncertainties of using the POD for hematologic effects from the Bruckner et al. Study. Respondents generally agree that the Kirk study was acceptable for derivation of an acute exposure point of departure study via the oral and dermal routes. However, EPA should consider the limited dermal absorption noted in human skin when deriving the dermal value. One respondent noted that EPA indicates that acute and short-term studies are more appropriate for chronic PODs than the chronic studies. However, this should only be determined after close examination of the PODs. In regards to the acute oral, the acute exposures do not require allometric scaling, and a recommendation is that EPA revisit the allometric scaling of the acute oral data. Regarding the acute inhalation, extrapolation from acute needs correction due to the allometric scaling. The acute central nervous system effects appear to have been observed in an inhalation study. EPA may want to consider those instead of extrapolation. So it's recommended that they correct the extrapolated value and or consider using central nervous system effects using effects from inhalation studies. Regarding acute dermal, the extrapolation from acute needs correction due to the allometric scaling. EPA needs to consider the limited dermal absorption noted in human skin when deriving the dermal value. So our recommendation would be to correct the oral value and correct for the absorption issues. Regarding the intermediate, chronic, and oral, Kirk,
let me pause for just a minute. And I apologize. So are you talking about the Bruckner study now?
I was talking about the Bruckner study. Yes, I went on to the Bruckner study. So the question 3AI regarding hematological.
Do we have comments and recommendations around the Kirk study?
So the Kirk study would be that it would be acceptable for derivation of an intermediate exposure point of departure via oral and dermal routes, but EPA needs to consider the limited dermal absorption noted in human when deriving the dermal value.
Okay, let's pause because that's 3A. That's your recommendation for 3A. It's related to the Kirk study.
Correct.
And let's see if anybody in any of the rest of the discussants have anything to add to just that piece. Okay, and I will go to Dr. Shin.
I think that the lead discussant summarized the strength and uncertainties of this Koch et al. Study. I agree with her, and I also noted that there's a wide acute no IL and low IL interval. So I think that US EPA needs to consider that. Other than that, I think that this is fine to me.
Okay, all right. Dr. Baranko, do you have anything to add?
Nothing further.
Okay. Dr. Thompson?
Yes, I just wanted to, sorry, with regard to the issue about the allometric scaling. So what we're looking at is we're referencing EPA's recommended use of body weight 3/4 as a default method in derivation of oral reference doses from 2011. And the relevant text there says that body weight 3/4 scaling is understood to address aspects of both TK and TD, the latter being inclusive of many repair types of processes. Body weight 3/4 scaling would not generally be relevant in cases of single exposures eliciting sudden or severe toxicity resulting in immediate or intolerable damage to some critical biological pathway. So I think you could include CNS there. And where repair processes, i.e. toxicodynamic processes, would be overwhelmed. This case is in contrast to chronic exposures where the organism or tissue has time available to repair processes to be elicited and functional, and where the level of damage is not severe. Example, those routinely considered for an RFD. So I think this is, as we set the stage for some of the discussions, that this is maybe a cross-cutting issue across some of the other assessments where allometric scaling has been used for acute oral points of departure, whereas I think the EPA guidance would suggest that that may not be appropriate. And then, of course, when you begin extrapolating across routes from that oral allometrically scaled value, I think you compound the potential errors, if you will, in the points of departure. So that's the reason for this comment about the allometric scaling. And we think that EPA should revisit or address how their allometric scaling comports with the guidance on that topic.
Okay.
Also, there was discussion in the assessment that there were inhalation studies, acute inhalation studies, where CNS effects were observed. And so I think another recommendation would be to, instead of extrapolating from the oral CNS effects, to look at those studies and consider using those as well as a potential point of departure for acute inhalation effects.
Okay, thank you. And Dr. Haver, do you have anything to add?
Not for this charge question.
Okay, thank you. And I'll open it up to The rest of the SACC, does anybody else have comments on charge question 3A? Okay, if not, I will ask the EPA if they have any clarifying questions.
No. Thank you.
All right.
We do.
Okay.
Okay.
Anna Lowett, Senior Science Advisor, OPPT. Just a couple of specific questions. I appreciate the clear and concise recommendations. That's extremely helpful. But as I read the question as it's written, it says, please comment on the strengths and uncertainties relevant to the study. I didn't hear the panel discuss the strengths of the study at all. So we would make sure that, that was included because it is part of the question. My other clarification is that what I heard from the speakers was the use of the Kirk study for acute and intermediate. Does that also involve chronic, or maybe we don't have chronic oral exposure or dermal exposure, although we should because it's a worker thing. And after you answer my first two clarification questions, it's important that we read 3AI into the record before you begin the deliberation of that one. So if we can do the clarification on ensuring that all aspects of the bolded part of that question are included in the comments, and my clarification about intermediate and chronic or intermediate only. Thank you.
Would any of the discussants from that charge question 3A like to respond?
I think this comment is about the intermediate point of departure, which I believe is the change in the reticulocytes. And one question that we had about that is that when we looked at the study, I think only the cell metrics were presented as percentages and not cell counts, such as mean and standard deviation. And I think a recommendation would be to either check with a statistician or perhaps an expert in BMD modeling to address whether it is appropriate to model the percent data as a continuous variable, or whether EPA should attempt to obtain the cell count data, or potentially, if that's not possible, consider another endpoint.
And I can talk about the strength of this study. I think that the principal strength of this study is the study quality is good, and then it's consistent with the broader toxicology database. And this study used controls and 3 dose groups in 2 species with relatively good group sizes for a developmental study, and the randomization was used.
Okay, thank you.
Yeah, I'll add on the study quality. We agreed that it evaluated the most sensitive endpoint being CNS depression, and it was positive that that was observed in humans also.
Okay, thank you.
And I have another summary from a respondent regarding the strengths and uncertainties of the Kirk study. The principal strengths are the quality of the study and consistency with the broader toxicology database. The study used controls and 3 dose groups in 2 species with relatively good group sizes for a developmental study. Randomization was used. Uncertainties include the wide acute no-L, low-L interval, pregnancy-specific testing, reliance on root-to-root extrapolation, and use of a 13-day study to represent chronic exposure.
Okay. Any other thoughts or comments from the committee in response to EPA's questions? EPA, any other clarifying questions? Did that address your questions?
It did in part, but I would just ask, because I think we should probably move on, that when the panel responds to this question, that there's still some comments about the Bruckner study and in the discussion of the Kirk study. And if we can just make sure the write-up is clear about the strengths and uncertainties of the Kirk study and then the Bruckner study, and understanding that the interaction of those two needs discussion. But and so just ask the panel to be clear in its write-up about the two, and remembering that we haven't officially on the record moved on to I yet.
Okay. Well, I will introduce I before we go on. We'll go back to 3AI and start from there. Anything else related to 3A? Okay, we will get EPA again. Let's put 3AI up on the screen. And again, we'll give a few moments to look at the introduction.
Please, this is Neria Rentis, EPA. Please comment on the strength and characterization of the uncertainties underlying a potential selection of a POD for hematological effects from the Bruckner et al. 1989 study for intermediate and chronic oral risk assessment.
Thank you for reading that into the record. And I will go back to Dr. Ryer-Powder to start our discussion as the lead discussant on 3AI.
So the group generally agreed that the Bruckner et al. 1989 study is valuable as an alternative and supporting study for hematological hazard identification because it directly evaluates non-pregnant adult rats for 13 weeks and demonstrated a coherent pattern of hemolytic anemia. It is more directly aligned with intermediate exposure duration than the Kirk study. However, it is not a strong standalone basis for a quantitative POD because no overall hematological no adverse effect level was identified, and high dose mortality complicates the dose response.
Okay. So I'll go to your associate discussants. Dr. Shin.
I have not.
Okay. Dr. Barranco.
Yeah, I can just add that the Bruckner 1989 study, I think, is worthwhile considering, given it was a 13-week study as opposed to 10 days in the Kirk rabbit study. And the anemia findings were shown in both species.
Okay. Thank you. Dr. Thompson.
I have nothing further to add.
Okay. Dr. Haber.
I also have nothing further to add.
Okay. Anybody else from the committee have comments related to this charge question? Okay, I will go to the EPA for any clarifying questions.
No, thank you.
Okay. All right, we will go to charge question 3AII.
Is there a 3AII?
I'm sorry, I'm looking at the wrong part of the agenda. It would be 3B.
Thank goodness for that.
Yes. Okay, here's the question. And EPA, if you would read the charge into the record.
This is Neria Rentis, EPA, reading into the record question 3B. Please comment on the strengths and characterization of uncertainties of the Dow Chemical 1988 study and the selected endpoints for intermediate and chronic inhalation PODs for 1,2-dichloropropane.
Okay. And again, I think Dr. Ryer Power is our lead discussant.
Yes, so the Dow chemical study was a GLP compliance study with a high quality determination according to agency criteria. According to the study report, nasal lesions, for example, olfactory epithelial degeneration, respiratory epithelium hyperplasia, exhibited dose response increases in both incidence and severity, both in male and female rats. In the same study report, degeneration of the olfactory epithelium was considered test article related in rabbits at higher exposure concentration of 1,000 ppm. The rat findings, absent any severe accompanying effect on general animal health, for example, mortality, body weight, and other overt signs of toxicity, collectively suggested a test article related effect. Therefore, the committee agreed that the more sensitive finding of the two, which is the respiratory epithelial hyperplasia, be used as a toxicological endpoint for intermediate chronic inhalation point of departure derivation. Ideally, this study would have included a pathologist narrative commenting on the findings. I have another comment regarding the Dow chemical study. 13 weeks is relevant to intermediate exposure, unlike a short-term study extrapolated to several months. Its 13-week duration directly supports an intermediate POD. The study directly used inhalation exposure. The concern is the quantitative derivation of the 0.25 milligram per meter cubed BMCL10 because it is several fold below the modeled HEC.
Okay. Dr. Shin, do you have anything to add?
No, I think that she captured well.
Okay. Dr. Bronco?
Nothing to add.
Okay. Dr. Thompson?
Yeah, so I think there are two issues with the pod that I think is worth discussing here. The first is with regard, and both of these issues I'm going to bring up are going to be cross-cutting, and some of the other colleagues on the SACC can weigh in. Pardon me. With regard to the BMD modeling, we've modeled the results, and it looks like there are other obviously the BMDS software recommended the Hill model, and we can see that by redoing the modeling ourselves. But there were also other viable models that provided about a threefold higher bench BMDL, and I think the model was recommended. The Hill model was recommended simply because it was the lowest, which is what the BMDS software is doing because it's looking at EPA's BMD guidance. However, this would be a case, given the variability in the model results, of potentially using the Bayesian model average for this endpoint, which didn't see that was discussed or even maybe conducted. And given discussions we had yesterday about other endpoints where there were no model fits and the Bayesian BMD modeling was used for pod derivation, it's a little unclear why here, when there is certainly the data can be fit, rather than use just simply the lowest BMDL, why not use the Bayesian model average output? And I think some of the other colleagues will weigh in there. The other issue with the point of departure is that the extrapolation of that point of departure from rats to humans is using EPA guidance from 1994 with regard to the regional gas dose ratio. For the extrathoracic region, which is correct, the extrathoracic region is correct, but it is using the old guidance where the dosimetric adjustment factor is roughly at 0.2 or less. And EPA has published multiple documents from, I think, 2009 to 2012, updating their recommendations on updating the overall recommendations on the 1994 RFC guidance. And the upshot of that is most of the approaches, I think, stand today versus the 1994 guidance, with the exception of the extrathoracic region, where EPA is recommending that for extrapolating air concentrations from rats to humans in that region, that it's just a 1-for-1. The DAF is actually 1. And that is based, I think, on sophisticated modeling that was conducted, chemicals like formaldehyde, with computational fluid dynamic modeling, et cetera. And the upshot of all of that research is that basically you can, the air concentration to the rat is delivering the same internal concentration in that region as humans. And so the DAF recommendation is now 1. And just to reiterate, that guidance was actually used in a recent EPA risk assessment of formaldehyde. So it is not just a guidance document living somewhere else. It has actually been implemented in other EPA risk assessments. And so the recommendation there is to reconsider the benchmark dose modeling for this endpoint, in particular, address the apparent lack of considering the Bayesian model average results, and then, which is a cross-cutting issue, as is the use of the outdated RGDR for the extrathoracic region. And so the recommendation is that EPA address the BMD modeling issue as well as the use of the outdated RGDR. Thank you.
Thank you. Dr. Haber, do you have anything to add?
Yes, just a couple of things to add to Dr. Thompson's comments. So one aspect of scientific support for the use of the Bayesian model averaging is that this is a case where there's clearly model-dependent uncertainty, and that's exactly what the Bayesian model averaging is useful for, as opposed to what we saw yesterday. And then with regard to the extrathoracic RGDR, just noting additional scientific support that in addition to being supported by the computational fluid dynamic modeling and other sophisticated analyses, that the 2012 document went through an analysis of the assumptions behind using the ratio of the inhalation rate to surface area, and determined that 2 of those key assumptions do not apply for the extrathoracic region. And so specifically, this using the RGDR of 1 addresses uncertainties that also tend to be noted about the wide variety of cell types in the rodent nose, as well as differences between the rodents and humans in nasal architecture. So additional support for the RGDR of 1. Thank you.
Thank you. Anybody else from the committee like to address this question? Okay, seeing no hands. EPA, do you have any clarifying questions?
Yes, thanks, Anna Lowett, Senior Science Advisor. I do. I really appreciate the clarity of those responses, but our uncertainty is in the additions that Dr. Thompson and Dr. Haber added. Are those consensus recommendations or are those individual recommendations? And it's important that the report reflect that. If those are minority views, or do those reflect the consensus? I would appreciate either an understanding of that now or an understanding of that before the meeting concludes at the end of the week, if possible.
Well, I'll respond first. I think at this point, we're getting consensus within the discussant groups. I don't know if we'll have overall committee consensus before the meeting's over. So I think we can discuss it in terms of that group and whether they reach consensus. And Allie or Temu, correct me if I'm wrong.
I appreciate that, Dr. Anna Lowett. Again, I just want to I guess two understandings. My longtime understanding of these FACA meetings is that the content of the report should be a reflection of the content of the discussions. And so if there are going to be any changes to that consensus, we would want to make sure that that occurred during the public part of the meeting, or maybe I totally misunderstand and we can correct that. But I would also just reiterate what you heard from Dr. Beck yesterday, that because we are under court order deadlines, that our staff will begin the changes to these assessment immediately following this meeting as we wait for the report. But we will go ahead and make these changes. So understanding what those to-do items are for our team is very important. And Dr. Thompson and Dr. Haber made some important, very pointed suggestions for revisions. And we just want to ensure that there's agreement of the panel to make those changes, because they would require some resources on our part.
My response would be yes. We did not hear anybody disagree with those recommendations, and certainly the committee has time during these discussions to do that. So I would suggest that those would be the recommendations from the committee, unless someone has raised an issue in our verbal discussions.
I can state that I'm aligned with Dr. Haber and Thompson's.
Okay.
Okay, and I want to, this is Tamu Gibson, want to echo that in what you presented, Dr. Gentry. Those recommendations are brought forward only during the meeting. And if there are any minority or different varying viewpoints, those will be brought forward as well. The context of those recommendations, those primary recommendations, will be stated in the meeting. So anything that is stated in the meeting will go into the meeting minutes. We will not enter any information that is not stated within the meeting. We will provide to you short-term actionable recommendations per the agency's request. Thank you.
Dr. Lewitt, did that help?
It did, Anna Lewitt, again, it did, and thank you, Tamu, for that clarification. So I guess my request stands that if this at least subgroup that Dr. Thompson and Dr. Haber's suggestion are a consensus recommendation, it would be important for us to understand that as opposed to those are a minority opinion. So, but thank you. We can,
yes.
I guess if you want the opinion of the committee now, unless there is anyone who objects to these recommendations, if you do, raise your hand if you have a different opinion, but otherwise we would consider these the recommendations of the committee.
And I will also like to add, this is Tamu Gibson, is that we ask the committee for consensus in their charge, response to the charge. And we will set aside, if they have not reached consensus, we can break out into, thank you, waiting rooms where they can try to achieve consensus. And so to respond to your question, we can ensure that we all receive consensus recommendations and statements for your use. So we can look back at the charge that may be in question, and Dr. Gentry, if we can do that, so that we can close the loop on the agency's request.
Okay, maybe we can do that
Yes.
at outside meeting and then come back to the EPA with assurances on this.
Yes, thank you.
Dr. Irwin?
Yes, thank you. I was wondering, is it possible that I can ask a question?
Sure.
Yes, thank you very much. I was wondering, I have read the 2012 RFC guidance from the EPA, and in that document, they did actually calculate the extrathoracic RGDR value. My question is, I did see the other information later on in the document about the computational fluid dynamics model, and I was wondering what the number of humans were in that at the time of 2012, and if it was only one person at that time, is that sufficient to make this decision? Thank you.
Can anybody from that charge question group address this? If not, if we need to deliberate and come back, we can.
May I suggest, I can't answer that question directly. I think Dr. Burgoon indicated yesterday that he was in charge of the group at the time that released this document, so maybe he has more insight. I will just reiterate the bolded text from that document I think it's the executive summary. A primary finding for gas deposition in the ET region is that the internal target tissue dose equivalency between humans and rats is achieved through equivalency at the level of the externally applied concentration, i.e. for both rats and humans, the same external air concentration, rather than the adjusted by the ventilation and surface area, leads to the similar internal target tissue dose to the upper respiratory tract. But maybe Dr. Burgoon has some additional insight.
Thanks,
Dr.
Dr. Thompson. Yeah, I'd need a look to go back. I actually pulled it down, so I'm going to look really quick and see if I can find it. Sorry.
Well, we can always come back to this if the group needs some time to deliberate. Dr. Haber, do you have something to add?
Yes, I can't answer the question specifically as asked, but I consider the CFD modeling results more as support for the conclusion than the basis for the conclusion. And what I relied on more in being convinced by EPA's argument that the RGDR should be 1 was the aspect that 2 of the 3 assumptions that underlie the ratio of ventilation rate to surface area do not apply to the extrathoracic region. And then the actual numerical aspect came from the computational fluid dynamic modeling. But the absence of those 2, the aspect that 2 of those assumptions are violated and how they are violated definitely supports an RGDR larger than the ones that have been calculated.
Okay. Dr. Irwin, do we need to still come back to you on the number of people from the guidance?
Yes, I would like to know what the number of humans were in developing the model and by 2012, because that's important.
Okay, well, we'll confer on that and get back to you as soon as we can.
Yeah, it is my understanding that the RGDR should be 1 if it's a systemic effect, but in that document, they did calculate the RGDR extrathoracic value in an example, so.
Okay, Dr. Burgoon?
Thanks. So EPA does discuss this at length in that document, and then in the status report 1. I don't remember off the top of my head. I think it was more than 1 human. I know it was several rats were used, but with respect to humans, I think it was more than 1 human. But you need to go back to the status report 1, which EPA has. I think there's still EPA staff there who worked on it. Such as I think John Stanek is still at the agency. He's one of the co-authors. He could definitely speak to it. The other person who co-authored it is at the CDC, and she's easily trackable, and she would know for sure.
So would it be possible for us to just craft a recommendation about EPA revisiting that and not necessarily address every question at this point? EPA, are you comfortable with that? It sounds like at least this guidance needs to be revisited in relationship to this question.
I appreciate the recommendation to reach out to existing EPA staff who remain to get clarification on the 2012 guidance and its application to our assessments. I think that that's a reasonable thing. Thank you. Oh, and
Okay. Any other comments or clarifying questions from EPA or the committee? Okay, with that, I think we will move on to charge question 3C. So I think EPA can go ahead and read that into the record.
Maria Rentis, EPA, reading in question 3C. Please comment on strengths and characterization of uncertainties relevant to applying short-term duration hazard values to estimate hazard across other exposure durations. Please suggest other studies that EPA should consider for acute, intermediate, and chronic hazard values.
Okay, thank you for reading that into the record. And I will again go back to Dr. Ryer-Powder as a lead discussant to start off our discussion.
You're on mute, Dr. Ryer-Powder. Please start over.
I'm sorry about that. The committee agreed that extrapolation from intermediate hazard values to chronic hazard values was appropriate, assuming that the chronic studies were either of inadequate quality or there were no chronic studies. The committee advised that extrapolation from acute studies to intermediate or chronic should be avoided due to their potential insensitivity to adverse toxicological findings only manifesting over long-term exposure. Regarding alternative studies, the panel did agree that we were not given sufficient time to reevaluate the entire database for this chemical, so we were unable to comment on that part of the question at this time.
Okay, let's go to the other discussants. Dr. Shin, do you have anything to add?
No, I have none to add.
Okay, Dr. Barranco?
Nothing to add.
Okay, Dr. Thompson?
Nothing to add other than that the chronic values obviously will have to be addressed depending on what happens to the intermediate calculations.
Okay. Dr. Haber?
Nothing to add.
Okay, anybody else from the committee? Okay, seeing no hands. EPA, do you have any clarifying questions?
This is Maria Rentis of EPA. No other clarifying questions. Thank you.
All right. Thank you. So I think with the completion of those charge questions, we're going to change the agenda up slightly, and EPA, we're going to turn to you with responses from yesterday's meeting. If there are any you would like to enter into the record.
This is Maria Rentis of EPA. We are still working on the responses to the clarifying questions. So if the committee could continue with the agenda, we'll give a status update as soon as it's available. But
okay,
members
all
that
right.
are still working on it.
Okay. Well, I think again, due to some scheduling issues, if EPA is ready. Oh, Dr. Haber?
So in the pre-meeting, we talked about also adding comments that were not in the charge questions. Is now the time to do that? Or-
Well, we typically have to incorporate comments like as part of the response to the charge questions. But do you have something overarching or typically we're responding directly to the charge from the agency?
Okay, I'm a little confused since that's not what I heard a couple hours ago, but I may have misheard. So yes, this is an overarching issue.
Have we discussed this morning already, this topic?
Not the specific issue. I can hold off. It's fine.
Okay. All right. Let's move to charge question 5. Is EPA ready with charge question 5? We're having to skip 4A and B. Can we start with 5A? There we go. Okay, if everyone would read this introductory material. Okay. Well, now EPA can read the charge to the committee.
Andrew Middleton, EPA, reading in question 5A. Please comment on the strengths and characterization of uncertainties underlying the selection of necrosis in the olfactory tissue from Will Research 2001 for acute inhalation risk assessment. Please include in your comments considerations for applying this rodent endpoint in POD to humans, given differences in respiratory architecture between rats and humans, considering the dosimetric adjustment between species and the human equivalent concentration calculation.
Okay. I will turn to Dr. Thompson as the lead discussant to initiate our discussion on this charge question.
Yes, so the committee was in general agreement with EPA's selection of olfactory epithelial tissue necrosis from the Will Research study for acute inhalation risk assessment. However, several key issues and uncertainties were identified that EPA should address. The Will Research study authors stressed that the sensitivity of rats for exhibiting this olfactory epithelial damage, and the study directors themselves questioned the human relevance of the lesion. There are significant differences in the olfactory epithelial coverage between rats, which is estimated to be 50% of the epithelium, and humans, which is approximately 3%, coupled with the obligate nose breathing by the rats, makes these lesions highly uncertain for humans. And this uncertainty could potentially have been addressed if there are any mouse studies at similar exposure levels. So essentially, there is agreement that this could be used, but there are concerns about this particular endpoint. And as far as so there are some specific recommendations for this. That EPA should conduct dose response analysis and POD derivation for some of the other endpoints that were observed in the Will Research study, and then compare these pods. For example, I think there were some CNS effects and or maybe some pulmonary effects. I can't remember off the top of my head, but the we were also able to, I think EPA used a LOEC for this endpoint. And in fact, we were able to model at least region 4 had with the combined male and female endpoints, we were able to model that data in particular, and you could potentially get a point of departure there, and then compare those points of departure across the different endpoints. And related to the previous question, though, I think when you start comparing the pods across different endpoints, you have to be using the appropriate regional gas dose ratio if something is systemic or something is in the pulmonary region or something is in the extrathoracic region.
Okay, thank you. Mr. Wright, do you have anything to add?
Sorry, I couldn't get my audio back on. No, I have nothing to add.
Okay, thank you.
Thank you.
Dr. Ryer Powder, do you have anything to add?
No, I don't. Thank you.
Okay, Dr. Shin.
No, I'm fine. Thank you.
Okay, Dr. Haber.
Nothing to add.
Okay, and then any other committee members? Okay, with that, I will go to EPA for any clarifying questions.
Anna Lowett, Science Advisor, thanks for that very clear recommendation. I guess if it's, there's a little bit of confusion, so if the committee is suggesting that the olfactory epithelium is not a human relevant endpoint, how can you give some suggestions on in doing alternative benchmark dose analysis, judging, or how to do a weight of evidence analysis of determining how to weigh these alternative endpoints to the olfactory epithelium, given the requirement under the statute to do weight of evidence and ultimately do an unreasonable risk determination, how we would think about unreasonable risk when the endpoint may not be relevant to humans. If there's some characterization that you could provide to help out, that would be extremely helpful.
Yes, we could. We haven't done that at this point. I think we didn't conclude that it was not relevant to humans. I think the main point was to acknowledge those uncertainties and then compute some alternative points of departure from the same inhalation study and compare those points of departure at that point, and then make a determination there.
Dr. Lowett, does that provide some clarification?
It does, thank you.
Okay. All right. With that, I guess we'll move on to.
We have Dr. Dorson. He just raised his
I'm
hand.
sorry, Dr. Dorson.
Well, it just occurred to me that part of the point of departure, there was an additional uncertainty factor of 3 for a low EC to possible no EC. So that might be one approach to finesse the situation of an oversensitive tissue being used as a point of departure. Just a thought.
Okay. Thank you. Anyone else? Okay. With that, I guess we'll move to 5B. If EPA would read that into the record.
Andrew Middleton, EPA, reading in question 5B. Based on your responses to 5A, please suggest alternative approaches for acute inhalation risk assessment for 1,1,2-trichloroethane. Please include in your comments consideration of alternative points of departure.
Okay, thank you for reading that into the record. Go back to Dr. Thompson again to lead the discussion off.
And before you start, Dr. Thompson, can you please put the charge question slide back up on there too? Thank you. Okay, I'm finished.
Dr. Thompson?
Yeah, so this really relates, I think, to something we've already covered in the previous response, but the committee generally agrees with some of the public comments that the dose response issues from the pod pose an issue, and therefore that the EPA should actually present those pods or present multiple pods from that study so that one can compare those points of departure and selecting amongst a more health protective value. So really the recommendation is to, as we said, try to conduct benchmark dose modeling on the necrosis itself, as well as some of the other endpoints. And then once they have been corrected to their human equivalent concentration, then that would then inform selection of the appropriate endpoint. One of the one of the committee members also suggested some NAM, did EPA consider some NAM-based approaches, such as in vitro air-liquid interface cellular assays, or some in silico quantitative structure activity relationships, and PBK modeling or read across for this endpoint.
Okay, thank you. We'll go to the associate discussants. Mr. Wright, do you have anything to add?
No, I do not.
Okay. Dr. Ryer-Powder?
Not sure if Dr. Thompson said this directly, but I just did a search to see if there was a recent publication regarding alternative approaches. And there is an article entitled Hybrid Model Development Through the Integration of Quantitative Read-Across Hypothesis with the QSAR Framework and Alternative Risk Assessment of Acute Inhalation Toxicity Testing in Rats. And my only recommendation would be that EPA take a look at that and make sure that they're considering all of the most recent methodology for doing this.
Okay.
And as a reminder, for those of you speaking, please turn your video on. If you're not speaking, please turn your video off. Thank you.
Okay, Dr. Shin?
I have none to add.
Okay, Dr. Haber?
I have nothing to add.
Okay. Any comments from anyone else on the committee? Okay. Any clarifying questions from EPA?
Andrew Middleton, EPA. No, we do not have any clear.
Okay. All right. With that, we will move on to charge question 5C. If EPA will put that on the screen, and please read it into the record.
Andrew Middleton, EPA, question 5C. Please comment on the strengths and uncertainties underlying the use of the Will Research 2001 and Nicholson et al. 1993 studies for evaluating risk from 1,1,2-trichloroethane inhalation exposures lasting less than 24 hours.
Thank you for reading that into the record. And again, back to Dr. Thompson to start our discussion.
And once again, please put the charge question slide on there. Thank you.
Yes, the committee agreed that the 1 hour CNS effects in Nicholson et al. Were likely too uncertain to use for the acute value for two reasons. One, there is greater uncertainty in extrapolating the 1 hour effects versus the 4 hour effects in the Will research study to 24 hours. And it is also likely that these CNS effects are driven more by concentration than a C times T, so the Haber's law is not applicable here. And so for that reason, we did not think that it was a stronger candidate for the acute point of departure.
Okay, thank you. And now to the associates. Dr. Shin, do you have anything to add?
No.
Okay. Dr. Ryer Power?
No.
And I'm sorry, Mr. Wright?
No.
Okay. Dr. Haber?
Nothing to add.
Okay. Anybody else from the committee? Okay. Any clarifying questions from EPA?
This is Andrew Middleton with EPA. No, we do not have any clarifying questions at this time.
Okay. All right. We'll move on to charge question 6. There's just 6, no A, B, I. So if you'll put the introductory, well, we can read that real quickly. And if EPA will read the charge into the record.
Andrew Middleton, EPA. Please comment on the strengths and characterization of uncertainties underlying the selection of the lesions, in the olfactory tissue from Will Research 2002 for intermediate and chronic inhalation risk assessment. Please include in your comments considerations for applying this rodent endpoint and POD to humans, given differences in respiratory architecture between rats and humans, considering the dosimetric adjustment between species and the human equivalent concentration calculation. In addition, please include in your comments a consideration of the use of a 90-day toxicity study to represent chronic exposure duration.
Okay, thank you for reading that into the record. And I will turn to Dr. Baracco as our lead discussant.
Okay, well, once again, can you please display the charge question slide? Thank you. It's displayed now. Thank you.
As an introductory summary for charge question number 6, the draft risk evaluation for 112 TCE identifies lesions in the olfactory epithelium of the upper respiratory tract in rats following inhalation exposure, from which point of departure values are derived for intermediate and chronic inhalation exposure durations. Committee agrees with the agency's conclusion that the findings in rodents are human relevant given the presence of the impacted olfactory cell population in either species and the application of an uncertainty factor to facilitate extrapolation to chronic exposure risk assessment. However, the committee recommends the agency modify the regional gas dose ratio for extrathoracic effects to better reflect the best science, to add additional detail on the agency's electing to assign a no observed adverse effect concentration in the Will Research 2002 study that differed from the study author's designation, and to reconsider various aspects of the benchmark dose modeling. Scientific rationale supporting the introductory summary include the following. The Will Research 2002 study is a high-quality, scientifically credible basis for identifying repeated exposure-related inhalation toxicity due to findings of toxicity occurring at lower concentrations than identified in the Nicholson 1993 study. Key strengths include it's a high quality, good laboratory practice compliant guideline study, included the evaluation of both sexes and a comprehensive nasal histopathology assessment. Strong exposure response relationships were identified. Availability of incidence data suitable for benchmark dose modeling is presented. It utilizes the appropriate exposure route for accumulation and assessment. The exposure duration is suitable for repeat dose risk assessment. The exposures are well characterized with exposure concentration relationships identified, and the study includes a clear identification of a histopathological endpoint that is biologically adverse. In addition, the rat olfactory tissue is highly sensitive and has an established history in inhalation tox. so that lesions can be consistently detected, interpreted histologically, and correlated with predicted local doses to the nasal mucosa, all in support of human risk assessment. Finally, there is no known chronic study via the inhalation route of administration with which to evaluate chronic toxicity of 112 TCE, particularly at the site of first contact, and as per EPA guideline 2002, extrapolation from the 90-day study to a chronic study is proposed via application of an uncertainty factor of 10. Weaknesses of the Will Research 2002 study design is that no recovery or interim observations are included. Contributing uncertainty to the study is the fact that species differences exist in gross nasal passage architecture, including rodents claiming more complex turbinate structure and different airflow patterns than humans, and relative abundance of the target tissue, including the fact that olfactory epithelium covers approximately 50% of the nasal cavity in rats versus 3% in humans. These differences can impact relative sensitivity to nasal tissue toxins and create uncertainty in quantitative extrapolation, as mentioned in the study report. It is also important to consider that the local metabolism and cell type distribution differs between species, and that rats may generate higher concentrations of reactive metabolites within the olfactory mucosa than humans, which could lead to different toxicodynamic responses. Despite these differences, the microscopic anatomy and function of the olfactory epithelium is similar between species. Therefore, the rodent is expected to be a useful animal model for detection of toxicological hazards in that specific subregion of the upper respiratory tract as it applies to humans. There is also a lack of similar findings of necrosis in the olfactory tissue following controlled human exposure studies or occupational epidemiology, but this may be due to the expected lower exposure concentrations in humans when compared to those conducted in animals. The Will Research 2002 study authors designate 15 part per million as the study no observed adverse effect concentration when reasoning the uncertainty of the finding at the exposure concentrations are not considered toxicologically significant, stating that they are not accompanied by frank cellular injury. Alternatively, the EPA considers 15 part per million the lowest observed adverse effect concentration and conducted benchmark dose modeling based on the olfactory epithelium findings noted at that exposure, including vacuolization and cyst formation in the olfactory epithelium. The interspecies differences in tissue dosimetry are largely accounted for by using the approach to the regional gas dose ratio calculation in the US EPA 2012 update to the reference concentration guidance. While the 1994 US EPA reference concentration guidelines described the extrathoracic regional gas dose ratio as being calculated based on ratios of minute volumes and surface areas for the experimental animals and humans, the 2012 reevaluation of reference concentrations methods changed this approach based on considerations of the assumptions underlying the use of these ratios. And the 2012 guidance concluded that the assumptions do not hold for the extrathoracic region based on non-uniform airflow and wide variety of cell types in the extrathoracic region. The 2012 guideline also noted that computational fluid dynamic modeling indicates that a regional gas dose ratio of 1 is appropriate or health protective for the extrathoracic region. Therefore, the most recent EPA guidance is to use a regional gas dose ratio of 1 for extrathoracic region. The transparency in the document for the benchmark dose modeling showing both the full input data and all the output was considered helpful. However, in table B923, showing the benchmark dose output for the point of departure for the subchronic study, several models are repeated with different results. Examples being the Hill Gamma and log logistic, and the reason for the repeated models with different results is unclear. The model chosen by EPA is also repeated, but the results are the same. Under the modeling conditions used by EPA, the multi-stage 1 model appears to be the optimal model for benchmark dose modeling. The two other models with similar AIC values, logistic and probic, have much larger scale residuals at the control and near the benchmark dose. However, rather than limiting the multi-stage model to a degree of 1, a more common approach is to run the data with the maximum multi-stage degree of n-1. When this approach is followed, the multi-stage 3 model is the best. The multi-stage AIC 82.241. The multi-stage AIC is 82.241. The p-value is 0.964, and the BMCL is slightly higher at 23.037. Thus, there is a minimal impact on the BMCL, but the fit is much better and the confidence is higher. Regarding minority opinions, there were none expressed by the committee. As for committee recommendations, the committee recommends the EPA further detail in the risk evaluation why they have elected to independently designate the 15 part per million exposure as the lowest observed adverse effect level relative to its designation as the no observed adverse effect level by the study authors in the Will Research 2002 study report, and subsequently conducted benchmark dose analysis based on respiratory findings of olfactory epithelium vacuolization and cyst at that exposure concentration, rather than findings at the exposure concentration the authors considered adverse, greater than or equal to 40 part per million, which included olfactory epithelium atrophy and respiratory epithelium metaplasia. If the critical effect remains vacuolization and cyst, the committee advises the agency that the BMCL modeling should be rerun with maximum multi-stage degrees of N-1. In general, if other endpoints are chosen, it is preferred to limit the degree to N-1 rather than 1 to allow the greatest flexibility in choice model. The committee recommends the agency use a 1 for the extrathoracic regional gas dose ratio based on the 2012 guidance, rather than a regional gas dose ratio based on the ratio of animal and human minute volumes and surface area. The regional gas dose ratio of 1 is preferred over the approach in the 1994 reference concentration guidance because the assumption underlying the calculation in the 1994 guidance do not hold for the exothoracic region based on the non-uniform airflow and wide variety of cell types in the exothoracic region. Finally, there are a number of areas where additional documentation can be useful for improved transparency and to aid in an independent evaluation of the assessment. First being, the committee advises the agency to explain that the dosimetric adjustment factor for allometric scaling is applied to the oral dose as opposed to inhalation concentrations or to a cancer slope factor. Secondly, in general, it was useful that the EPA authors provided the equation and basis for the human equivalent concentration calculations. However, the committee advises the agency that there are several aspects that could benefit from improved documentation. Documentation of the approach for calculating the regional gas dose ratio for the extrathoracic effects in the Will Research 2002 study is confusing and incomplete. Tables 212 and 216 provide the regional gas dose ratio and note that it is based on the study-specific animal body weight, but that statement leaves out the majority of the calculation. The format used in prior IRIS summaries would be useful. See 1,2-dichloropropane IRIS summary and reference concentration documentation. Given study-specific body weights were used to calculate the rodent minute volume, the equation used to calculate the minute volume and the resulting value should be shown. Next, rather than using a ventilation rate based on adults at rest, the committee recommends that the ventilation rate be based on light activity. This is the approach used in the US EPA 1994 reference concentration guidance and is more health protective. The committee advises the agency that in table appendix B6, the column labeled BMCL10 should be labeled adjusted BMCL10, since it reflects the BMCL10 adjusted to continuous exposure. Committee advises the agency to review table 5.4. It is not clear what the first line in the BMC column refers to. And finally, the committee advises the agency to address why BMCL modeling of the acute study was not done. This concludes the SACC committee's comments on charge question number 6.
Okay, thank you. I'll move to the associate discussants, Dr. Shin, excuse me.
Not provide.
Okay, Mr. Wright.
I'm fine with the statement as it is.
Okay. Dr. Ryer-Powder?
No, I'm fine with the statement as it is. I thought that was a great summary. Thank you.
Thank you. Dr. Dorson?
Yeah, it's a good statement. Thank you very much, Dr. Wade, or Dr. Baracco. One thing to add is that, and this is a kind of a question with benchmark dose modeling and the precision of the outputs. As we all learned in high school chemistry class, we can't have derived values any more precise than the incoming data. Most of the data in these studies are, doses are 2, arguably sometimes 3 digits of precision. And so the outputs of the models shouldn't be any more than 2 digits of precision. I know that's what the models put out when they put out 8 and 10 digits, but we need to recognize that not everybody is numerically literate, and we need to sharpen up our precision and make it appropriate for benchmark dosing and other derived values. Thank you.
Okay. Thank you. Dr. Haber.
Nothing to add to that very complete summary.
Okay, thank you. Any other committee members? Okay, EPA, any clarifying questions?
Andrew Middleton, EPA. No, we do not have any clarifying questions at this time.
Okay. All right, I guess with that, we will move to charge question 7. EPA, if you will read, well, give you a moment for the introductory material. Okay, EPA, if you will read the charge into the record.
Andrew Middleton, EPA, reading charge question 7. Please comment on the strengths and characterization of the uncertainties underlying selection of decreased motor activity observed in the Will Research 2004 for acute oral and dermal risk assessment for 1,1,2-trichloroethane. Please suggest other studies and/or endpoints that EPA should consider for the acute oral and dermal hazard values. Please consider the duration of dosing, method of dosing, dose response, and the physical chemical properties of 1,1,2-trichloroethane.
Okay, I'll turn it back to Dr. Baranko to start our discussion.
Okay, so the charge question slide has to be on the screen. And then also as a reminder to everybody, when you're reading your responses into the record, please think about your pacing. Please don't read too fast. Please enunciate your words well. Understand that we are taking a recording here. The transcriptionist is transcribing everything that's being said. And plus the program office is listening carefully to the response and is taking notes and may provide a response. So please pace yourself well when you read your response into the record. All right, thank you. Okay, the slide's up too. Thank you.
As an introductory summary for charge question number 7, the draft risk evaluation on 112 TCE identifies decreased motor activity in rats following acute oral exposure, from which point of departure values for acute oral and dermal exposure durations are derived, being study Will Research 2004. Committee supports the agency's conclusion that the findings in rodents are suitable for acute oral point of departure derivation, yet advises the agency to provide further details on their designation of the no observed adverse effect level and lowest observed adverse effect level in the study. Furthermore, the committee requests the agency reconsider route-to-route extrapolation from the acute oral study to derive an acute dermal point of departure when alternative options are available. Scientific rationale supporting the introductory summary include the following. Strengths of the Will Research 2004 study include assessment of quantitative motor activity measurements, the observation of decreased motor activity presenting in 112 TCE orally dosed rats in a dose-dependent manner, appropriate peak effect timing, the evaluation of both genders, and that the exposure duration is appropriate for acute hazard assessment. These factors help identify it as the best study for supporting the development of acute oral hazard values. Uncertainties in the Will Research 2004 study design include a lack of accompanying systemic exposure data in the test animal and inconsistencies in motor activity responses between genders evaluated. The Will Research 2004 study authors designate the 55 mg/kg dose of 112 TCE as the no observed effect level, and the 95 mg/kg dose as the no observed adverse effect level, which is unique to the EPA's designation of the no observed adverse effect level as 55 mg/kg and the lowest observed adverse effect level at 95 mg/kg. Uncertainty stated by the study authors as to their reluctance to use more severe effect level designation was that findings noted at the 95 mg/kg dose exhibited reversibility and are not noted in the study's functional observation battery. Neurotoxicity findings are not observed after acute dermal administration of 112 TCE in various animal species, including the rabbit, Dow Chemical 1956, and the guinea pig in Cronevi 1977. At considerably higher doses than the acute oral study, Will Research 2004, which suggests reduced sensitivity via the dermal route. However, those studies are of varying quality and presumably only evaluated overt neurotoxicity. The Tyson 1983 study is not thought a superior study to the Will Research 2004 study for acute oral dermal risk assessment, particularly given the study did not include histological assessment of the rat livers to determine if there was a histopathological correlate with the serum transaminase changes induced by 112 TCE. Regarding alternative endpoints to consider for acute dermal risk assessment, available evidence supports consideration of acute dermal lethality and skin irritation as route-specific endpoints. Liver or neurotoxicity endpoints noted in acute oral studies can be used only in a route-to-route extrapolation framework supported by dermal absorption data. Additional alternative endpoints or data sources which might serve to refine the oral and dermal hazard value include 1. Generally, in acute inhalation studies, chlorinated solvents cause central nervous system depression following inhalation exposure. Inhalation studies may better characterize the concentration-response relationship for acute neurobehavioral effects, given that inhalation more closely reflects rapid systemic solvent uptake than gavage. If there is concordance across the oral and inhalation studies, this would strengthen that central nervous system depression is the critical acute value. Number 2, histological animal studies report clinical toxicity effects, including ataxia, narcosis, loss of riding reflex, impaired coordination, and reduced activity following acute exposure to 112 TCE. These studies may not have been conducted according to guidelines, but they may provide useful weight of evidence supporting central nervous system depression as the critical acute point. Number 3, developmental toxicity study report material. Developmental toxicity studies report maternal clinical observations following repeated dosing. If maternal effects occurred at doses comparable to the Will Research 2004 study, these findings would strengthen confidence in the selected point of departure. Number 4, human case reports following accidental exposure describe dizziness, CNS depression, and narcotic effects. This information cannot be used for quantitative point of departure derivation, but can contribute to biological plausibility. Number 5, regarding route read across PBPK modeling, a validated PBPK model could convert internal target tissue concentrations, for example, the Cmax in the brain and blood, from acute inhalation studies to equivalent internal doses for dermal scenarios. And finally, number 6, acute dermal studies in rodents or rabbits that evaluate local cutaneous endpoints, examples being severe dermal irritation and epidermal necrosis, should be considered since these effects occur at lower effective doses than systemic neurodepressive effects. Regarding minority opinions, there were none expressed by the committee. As for committee recommendations, the committee advises the agency to provide further detail in the risk evaluation as to why they designate a unique no observed adverse effect level and the lowest observed adverse effect level values in the Will Research 2004 study relative to those stated by the study author. Secondly, the committee advises that alternative endpoints or data sources for assessing the toxicological risk of 112 TCE following acute dermal exposure should be further considered by the agency. This concludes the SACC committee's comments on charge question number 7.
Thank you very much. And now I'll go to the associate discussant, Dr. Shin. Anything?
Yes, I think that for acute dermal risk, the endpoint seems to be relevant, but the administered oral POD should not be directly applied to dermal dose because skin retention, evaporation, contact conditions, and absorption kinetics must be incorporated.
Okay, thank you. Dr. Dorson.
Nothing to add here. Thank you. Well done. Summary.
Okay, Dr. Ryer Powder.
I'm in agreement with Dr. Shin.
Okay. All right, any other comments from the committee? Any clarifying questions from the EPA?
Andrew Middleton, EPA. No, we do not have any clarifying questions.
Okay. Thank you. Before we move on, to those listening, there may have been some surprises with the change in the agenda. We have had some unexpected scheduling issues with some of our committee members, and we've had to move some things around. So we have the lead, the discussants and lead discussants available for the charge question. So that's part of the reason. And also, we had a lot of clarifying questions yesterday. We had hoped to address those first thing this morning, but EPA needs some more time to address all those questions. So we are moving forward with the agenda. You will notice we're not exactly with the agenda that's been published, and we're moving things around. But basically, we started with charge question 3 this morning. We had to move to 5 after that. And since then, we have been following the agenda in question order. So I just wanted to bring that up in case people have joined since we started the meeting this morning. And at this point, we are ready to move on to charge question 8A, unless there's anything else that needs to be added to Muir Alley.
I have nothing more to add, and I'm just wondering if and please let, for the program office, let us know when you're ready for your responses to yesterday's discussions and clarifying questions when it's ready to be read into the record. Thank you.
And this is Tam U. Gibson. Excuse me, one note, there is a note on the agenda stating that the times are approximate as well as the sequence of charge question deliberations may change based upon availability. So that note is there for you on the agenda, on the meeting agenda. Thank you.
Okay. Everyone will take a moment to look at the introductory material for question 8. Okay, EPA, if you will move on to the charge to the committee for 8A.
Andrew Middleton, EPA, reading in question 8A to the record. Please comment on the strengths and characterization of the uncertainties underlying selection of the Sanders 1985 study and selection of the TDAR hemagglutination endpoint in mice, Sanders et al. 1985, for the intermediate and chronic oral and dermal risk assessment. Please include in your comments a consideration of the study quality and associated high rating for the Sanders 1985 study.
Thank you for reading that into the record. And with that, I will turn it over to our lead discussant, Dr. Derelson.
And once again, I have to a reminder, please put the charge question slide on the screen so that we will. Thank you. Okay. I'm sorry, Dr. Derson.
No worries. Top of the day to you, gentle people. This is a difficult area, and I'm glad EPA's asked the questions. The committee itself is not of one mind on this particular response to the question. What I'm going to do is give you a number of strengths, issues, and caveats, no doubt, which our EPA colleagues already know. Some of these issues and caveats were raised by committee members, others in public comments. And some of these issues apply and caveats apply to other immunotox studies in this suite, in this chemical. So the Sanders study evaluated multiple immune endpoints. This is good. It did the T cell dependent antibody response, which is a very good assay. This assay is generally more sensitive than other structural changes, another good thing. And the Sanders study identified, effects on humoral immunity and several of these things. However, Sanders only reported liver weights, but not thymus weights in the 14 or 90-day study. The study also lacked lymphoid organ analysis histopathology, did not have a positive immunosuppressive control. The T cell dependent antigen response using sheep red blood cells and no delayed type hypersensitivity. Study also referred to statistically significant variations in control values from multiple different studies, which made the analysis of some of the statistically significant findings difficult. I'm sure our EPA colleagues were aware of that. The study was also conducted prior to EPA formal guidelines. Now, that's not necessarily bad in itself. And there's no indication it was good laboratory practice compliant. It doesn't meet EPA guideline requirements, but it does provide mechanistic and functional evidence. And sometimes, in fact, often EPA uses non-guideline studies to support, safety assessment. Overall, EPA's assignment of high-quality study rating appears to overestimate the study's rating. Now, that's not uniform. Some of our committee members think it is the gold standard for immunosuppression, and the study does get a high-quality rating. That's some of the issues that our group is still discussing. It's important to note that this is one of our other committee members, that no studies were identified through systematic review. No new studies were identified through systematic review or previous assessments that evaluated immunological effects on 1,12-trichloroethane in exposed humans. For a human hazard assessment, although a positive TDAR results in a mouse model implies there is an effect on humoral immunity, interpretation of the results of the assay would be strongest when examined as part of the weight of evidence, including epidemiology studies. So therefore, the magnitude of the immunological effect in humans is uncertain. Now, there were a couple additional things, gleaned from member review and public comments. I'll just list these. Again, we talked about the use of the outbred mouse where the control parameters among studies that are statistically significant different from each other. These are differences among controls of different studies. Somehow that's influencing results. It's difficult to tease that out. The studies were done at a time when various labs were exploring different assays. So this is back in the 80s. So everybody's trying to get a handle on immune effects, and these were just different assays. These assays described were not typical. The decreased hemagglutinin assay that for this chemical was crude and subject to inaccurate readings. But in contrast, the more accurate AFC assay showed no effect. And the AFC and hemagglutinin test should show similar trends as they're both measuring antibody responses to sheep red blood cells. So what does the committee recommend? Well, the committee will need to work through these caveats and public comments before we can make a judgment or a recommendation on the applicability of this study for safety assessment. If the immunotoxicity is maintained as a critical effect, however, the 90-day study is preferred over shorter-term safety assessments. And at this point, we don't have any recorded minority views because the committee still has to work through some of this. And that completes the response to Part A. Welcome, committee, my colleagues' additional comments or corrections.
Yes, I will turn to the associate discussants, Dr. Barranco.
Yeah, nothing to add. My viewpoint was expressed.
Okay, Dr. Thompson?
Nothing to add.
Okay. Dr. Powder?
Nothing to add, thank you.
Okay, and Dr. Klonick?
Nothing to add.
Okay, any other committee members?
This is Ali Munir from the EPA. I just want to say quickly that in listening to the response, it sounded like that there's no minority recommendation yet, no consensus on the recommendations yet, and there's still the team is still working on the response. I just want to say that once you have come up with your final response and you have identified your list of recommendations, if you have consensus, if you have reached consensus or not reached consensus, including a minority recommendation or opinion, please state that sometime this week. Because it sounds like if you guys are still working on this, your response, please finalize it this week and read it into the record. Thank you.
Okay, thank you.
Okay. I guess with that, we will move on to 8B.
Well, we haven't gone to the agency,
I'm
to the
sorry,
program.
you're
I'm
right.
sorry, because I interjected. I'm sorry.
That's fine. Any clarifying questions from the EPA?
Andrew Middleton, EPA. We will wait for the committee's further recommendations, but we don't have any clarifying questions at this point.
Dr. Dowson, we'll put this question on our list to revisit before the end of the week.
Sounds good.
Okay. All right. I think now we can move to 8B. Okay. I think EPA can go ahead and read that into the record.
Andrew Middleton, EPA, reading in 8B. In light of your comments to charge question 8A, if appropriate, EPA may seek and consider alternative approaches to hazard identification for 1,1,2-trichloroethane.
And I apologize, we have a 8BI. So we'll put that up for the introduction there. Okay, EPA, you can go ahead and read the charge in.
Andrew Middleton, EPA, reading in question 8BI. Please comment on the strengths and characterization of the uncertainties underlying the selection of immunosuppression from Sanders et al. 1985 as a potential POD following 14 days of exposure to 1,1,2-trichloroethane for intermediate and chronic oral and dermal risk assessment. Draft human health and environmental hazard assessment for 1,1,2-trichloroethane. See Table 2-11. Please consider the duration of dosing, method of dosing, dose response, and the physical chemical properties of 1,1,2-trichloroethane.
Okay, thank you. And I will go back to Dr. Dorson.
Okay, so thank you very much. Again, the committee is in process of doing this. There's a number of advantages, issues, and caveats determined by committee members and also described in public comments. Principal strength of the AFC assay is it directly measures antigen-specific antibody-producing plasma cells. It's widely regarded as a sensitive measure of humoral immune function and therefore provides, mechanistic evidence that's helpful. The 14-day exposure falls within EPA's intermediate duration window of 24 hours and 90 days. Okay. So therefore, it's qualitatively relevant to an intermediate oral risk assessment. However, this point of departure for chronic oral or dermal assessment introduces uncertainty because there are no longer duration AFC or TDAR data showing whether the immune suppression stabilizes, worsens, or resolves with continued exposure. The study also used gavage rather than drinking water, which is likely to be the human route. Gavage, of course, produces high peak internal concentrations, as we all know, may not reflect real-world exposure scenarios, may overemphasize peak-driven effects, while underrepresenting steady-state concentrations. The dose in this study is interpretation is also uncertain. There are only 2 treatment doses in addition to control, and the dose spacing was limited. So the response was relatively shallow, with 23% suppression at 3.8 milligram per kilogram per day and 31% suppression at 38 milligrams per kilogram per day, tenfold higher. Doesn't demonstrate a strong dose response trend. The magnitude of suppression was modest, and it's uncertain whether 3.8 milligram per kilogram per day is near a true NOEL or a low AL for immunosuppression. Now, again, the TDAR hemagglutinin endpoint is preferred over the AFC assay. Because, again, here's some of the strengths. It's the gold standard for such evaluations. It's derived from a 90-day study. And there's several other advantages, in this particular case. And the NOEL between the 14-day study and the 90-day are nearly identical. So this has applications for the use of an uncertainty factor from chronic, subchronic to chronic. In other words, if the 14-day and 90-day are essentially the same, then one might contemplate a lesser uncertainty factor of going from subchronic to chronic. I mean, that's a typical evaluation that people have done before. Another uncertainty in this study is that there are a limited number of evaluations performed. And again, some of the caveats that we talked about before, the use of the outbred mouse, where control parameters among studies were statistically significantly different. The control parameters were statistically significantly different. The studies were done, back in the 80s when there were various labs were exploring different assays, fine. And then the decreased hemagglutinin assay is subject to inaccurate readings, and the AFC assay has showed no effect. There are differences here that lead to some additional contemplation. So, recommendation, this is going to sound very familiar. The committee needs to work through these caveats and public comments before we can make a recommendation on, whether we can use this study for safety assessment. Fortunately, we do have other studies to look at, but if the immunotoxicity is maintained as a critical effect, then the committee thinks that the 90-day study is preferred over the 14-day study for safety assessment. And at this point, we don't have a minority view because we haven't fully discussed this question. Thank you, and I'll open it up for other members.
Okay. Dr. Bronco.
No, nothing to add.
Okay. Dr. Thompson.
Nothing to add at this time.
Okay. Dr. Ryer Powder.
I have nothing to add. Thank you.
Okay. And Mr. Klonick, Dr. Klonick, excuse me.
No problem. I have nothing to add, although I will add that Michael did an excellent job summarizing this difficult question at this time.
I think, well, let me go to the committee to see if anybody has anything to add. I think I will add, I know there's some opinions around, and it sounds like, I don't know if this would be applicable to this particular endpoint. Sounds like you have some studies, but there's uncertainty, and is there an issue with the database itself around this endpoint? And so I'm going to ask Dr. Haber to jump in. She's got an issue that it's hasn't been kind of discussed with any PODs so far, but I think we could introduce it with the challenges you're having with these endpoints.
Okay. Thank you, Dr. Gentry. So a general question I had about all of these assessments is that I saw no mention of the database uncertainty factor. So I'm not recommending that we use a factor of 10 or any specific factor for any of these assessments. But I think for transparency, the database uncertainty factor is part of EPA's methods for deriving RFDs, and that again, I don't think that this should be a checkbox approach, but that this issue of are there data gaps and what are the implications of such data gaps for identification of a critical effect and point of departure is an important part of this overall assessment and in all of the assessments.
So, and I would just add, I think this comment's relevant to several of the questions we've talked about so far, where there's uncertainty in the studies available for a particular endpoint. Anybody else from the committee? EPA, any clarifying questions? Sounds like I'm interrupting, but it sounds like we'll be coming back to this one as well.
Right.
Andrew Middleton, EPA. Yes, we will kind of see what the committee has to say in the final recommendations, but we don't have any clarifying questions at this point.
Okay. All right. I guess we will move to 8B2 II, 8B II. I think the EPA can go ahead and read the charge in.
Andrew Middleton, EPA, reading in question 8BII. Please comment on strengths and the characterization of uncertainties underlying the potential use of endpoints in White et al. 1985 for intermediate and chronic oral and dermal risk assessment. Please consider the duration of dosing, method of dosing, dose response, and the physical chemical properties of 1,1,2-trichloroethane.
Okay, I will turn it again over to Dr. Darson. Excuse
That's
me.
okay.
Okay,
I
well,
answer either.
yeah, very good. We need to have a slide on. Thank you. Okay.
Yeah, I answered either one. So here is now we're stepping through to these idea of alternate toxicities. And we're using the first question here is about, some of the studies we've already talked about. So we're going to get into, again, the strengths and some of the issues and caveats associated with this. So the study by White et al., the 85, A and B, have valuable supporting evidence in standard tox parameters in the mouse, the CD1 mouse. Several potential organs are identified. The use of gavage, which has its issues, of course, but it ensures a delivery of a certain dose, which is good. And there was reported changes in the weights of the thymus and the brain and the testes at doses of 38 milligram per kilogram per day. Well, these are relevant because the tissues are biologically possible targets. The findings in the thymus are particularly significant because it's supporting the immune system disruption potential. However, first caveat, these endpoints have significant limitations. The duration, why? Well, because the duration of the study is only 14 days. considerably shorter than 90. And we all know about progression, adaptation, reversibility, or cumulative toxicity under chronic exposure conditions. And of course, here's the contrast. The study does use bolus dosing, which has got advantages, but it's got, the higher peak internal concentrations. These are kinds of disadvantages and advantages that, toxicologists that do risk assessment see this all the time. In the case of the bolus, the toxicity might be driven by peak internal concentrations. And again, as described before, interpreting dose response is got some issues because the lowest observed adverse effect level of 38 milligram per kilogram per day and 3.8 the NOAA are useful for hazard identification, but changes in organ weight alone are difficult to interpret without additional supporting histopathology. For example, and this is gonna come up, brain, thymus, and testes weight changes when they were normalized to brain and or body weight were actually no different than controls. So even though they're seen as effects, normalized to body weight and to brain weight, which doesn't really change much as body weight increases or decreases, there just were no changes in these organ weights. So therefore, that's one of the difficulties. Let's see if there's another difficulty I want to say here. I'm reading from what's on our SharePoint. I think I've hit most of them. Okay, so let's go to the recommendations. I think some of these, again, this particular study was a series of studies that were doing control parameters, but that's really was more immune related. So what's our recommendation? Well, again, we need to work through these two studies in particular versus something else, a longer term study. But if we were given, these kinds of things, we're going to prefer these kind of endpoints. We're going to prefer a longer term study for the subchronic to chronic extrapolation. And that is not necessarily a committee consensus, but it's close to it. We're more or less agreeing on not using these non-immune effects from these shorter term studies as a basis of the safety assessment. And with that, I'll open this up to my colleagues on the committee.
Okay. Dr. Barranco?
Nothing to add.
Okay. Dr. Thompson?
Nothing to add at this time.
Okay. Dr. Ryer Powder?
Yeah, so I just wanted to emphasize that the duration of the study, of the White study, 14 days, is short relative to the latency of some of the developmental, reproductive, and neuroimmune effects. So it's possible that the study might have missed toxicity that emerges with a longer exposure.
Okay. Anything else?
Not from me.
Okay. Dr. Klonig?
I have nothing to add. Thank you.
Okay. Anybody else on the committee? I guess I would just add to your thoughts, Dr. Dorson, that it sounds like a short-term study with relying on effects that don't seem to be what we would typically call adverse or directly immune related. So sounds like lots of challenges and recommendations are needed around the use of this study.
Right. I think the committee is pretty uniform on the fact that if we use these studies for immune effects as a critical effect, that's fine. We may end up there. But to step it to something else within that study doesn't make a lot of sense, especially since, the organ weights are you do organ weight adjusted for body weight, there's no changes. I mean, there's just not there.
Okay. All right, anyone else? Any clarifying questions from the EPA?
Andrew Middleton, EPA. No, we do not have any clarifying questions at this time.
Okay. I think we'll still, to make sure everything related to question 8, we'll revisit, briefly towards the end of the week, especially where we don't have clear recommendations at this point. Okay. Let's see. So now we have charge question 8B III. Okay, EPA, will you read that into the record?
Andrew Middleton, EPA, reading in question 8B III. Please suggest any other studies and endpoints that EPA should consider for intermediate and chronic oral and dermal hazard values. Please consider the duration of dosing, method of dosing, dose response, and the physical chemical properties of 1,1,2-trichloroethane.
Okay, back to you, Dr. Dorson.
Okay. So the issue here is if immunotoxicity is not judged to be the critical effect, okay, then other studies will need to be considered, of course. You've got the 90-day drinking water studies by White et al. And Sanders. These are the immune studies that also have some other toxicities. That's certainly their candidate endpoints here include liver toxicity, serum chemistry changes, hepatic enzyme alterations, hematological changes in females, which are not necessarily immune related. So these are the 90-day studies. The 14-day gavage immunotox and tox studies could be retained as supporting evidence, but given less weight for chronic POD selection, as we've already previously discussed. Now, there's some other alternatives. For chronic oral values, the EPA should consider the NCI chronic gavage bioassay qualitatively for systemic target organ information, recognizing that it was designed primarily for cancer evaluation using gavage dosing. Now, one thing is interesting that we uncovered before is the 1978 NCI bioassays were really geared for looking for cancer. They really weren't looking for non-cancer toxicity. And this has an implication for how you evaluate that study with its non-cancer endpoints there or not there as part of the mode of action for cancer. We'll probably get to that later. But it's a study that's available, but it's not really good for non-cancer. It doesn't check all the boxes because it's looking for cancer. But still, it's an option. EPA should prioritize, kind of skipping around here, any available dermal absorption, dermal irritation, repeated dermal toxicity information, including OECD 428. And why? Because a volatile liquid may evaporate from skin before absorption is complete. So you can use these studies for dermal, but of course, you need to be aware of it's volatile. If you're going to put on the skin, you patch it to keep it from going away. Another alternative for intermediate oral value is a repeat oral dose study by Bruckner et al. 2001. Now, EPA mentions this as well. The study provides a repeated dose oral data and a clear intermediate no AL, no observed adverse effect level for overt toxicity. For a chronic oral value, the evidence base is weaker. We didn't locate any chronic reviews or any long-term road studies, so you might have to be ending up with an uncertainty factor for subchronic to chronic. There's a typical default of 10. Other people have used less. We heard that in the public comments yesterday. EPA has its own guidance that they could put forward. So those sort of the strengths, caveats, alternate choices. Well, what's our recommendation? Based on the outcome of the immunological review, so immune effects still may be critical, but let's say if they are not the critical effect, the committee suggests 2 other studies as possible basis for the safety assessment. That's the Bruckner et al. 2001 repeat oral dose study in rats, suitably adjusted, with an uncertainty factor for intermediate, but also adjusted with an uncertainty factor for chronic. Or the NCI 1978 chronic bioassay in rats and mice, recognizing that the latter study is primarily devoted to cancer findings. Possibly we'll develop a minority view on this. It really comes down to the immunological review. If it's not the critical effect, then we're going to probably be recommending either NCI or Bruckner or a combination of the two, one taking the lead, the other is supporting. And with that, I'll open it up to my colleagues.
Okay. Dr. Bronco?
Nothing to add.
Okay. Dr. Thompson?
Nothing to add at this time.
Okay. Dr. Ryer-Powder?
Nothing to add, thank you.
Okay. And Dr. Klonick?
I agree with Dr. Dorson's assessment. I have nothing to add.
Okay. Anybody else from the committee? Okay. EPA, any clarifying questions?
Andrew Middleton, EPA. No, we do not have any clarifying questions.
Okay. All right. Well, that will lead us to charge question 8C. EPA, please read that into the record.
Andrew Middleton, EPA, reading in question 8C. Please include in your comment the strengths and characterization of uncertainties relevant to conducting oral to dermal route-to-route extrapolation, considering the OECD 428 dermal absorption data, LabCorp Early Development 2023. In addition, please also include in your comments the consideration of extrapolation from a 90-day toxicity study to chronic exposure duration.
Thank you for reading that into the record. And again, back to Dr. Dorson.
Okay, so the issue identification is very simple. Since we don't have adequate dermal toxicity studies, a route-to-route extrapolation will be needed. And so I'll just read through what our committee is coming up with. The oral to dermal extrapolation is reasonable screening risk assessment approach when the critical effect is systemic and chemical specific dermal absorption data are available. The LabCorp OECD 428 provides measured percutaneous penetration values rather than relying on default theoretical permeability coefficients. In addition, the study accounts for chemical specific skin flux and mass balance and captures retention in the stratum corneum rather than penetration into receptor fluids. That's all good. However, we knew that was coming because, 112 trichloroethylene is volatile. Using an in vitro or open topical exposure conditions may underestimate evaporation losses from the skin with the potential to distort absolute absorbed dose, of course. Dermal application also has the potential to induce localized irritation damage. So high doses of this chemical can irritate or damage the skin. Probably not going to happen a lot. Maybe it will. Let's see, what else do we have here? Regarding limitations, again, some other limitations. Route to route often extrapolation often requires more than just absorption. There's distribution, metabolism, elimination, first pass effects, and they are not really addressed if only OECD 428 data are used. Now, of course, our EPA colleagues know this. So extrapolation from oral to dermal can be especially uncertain if the parent compound or metabolites undergo substantial first pass metabolism orally, which they apparently do here in the liver, because dermal exposure bypasses that pathway. 1,1,2 trichloroethylene also appears to undergo, well, oral first pass metabolism. Yes, it does. I've already said that. Sorry. So what is our recommendation? Well, the committee considered that while the extrapolation from oral to dermal isn't ideal, it should not be abandoned entirely. Rather, EPA should extend additional effort to try to optimize it more, if that's possible. Now, as to the use of uncertainty factor for subchronic to chronic exposure, of course, EPA will have to reconsider after selecting its critical effect. So if immune toxicity is its critical effect and we don't have many changes between 14-day and 90-day study, then a smaller uncertainty factor, maybe even a factor of 1, might be appropriate. If the critical effect is other than immune toxicity, then we've provided a table that presents points to consider for the use of this default factor of 10. I'll just kind of go over these really quick. Consideration, duration gap, of course. Chronic effects may appear only after longer exposure than 90 days. The critical effect, the endpoint driving risk may change with time. Dose response, a 90-day NOEL or benchmark dose may shift in a chronic study. ATSDR and EPA with its categorical regression method has found this to be the case when they do dose duration plots. So here's dose on the y-axis, a very odd place for it, and duration on the x. They see this shift in NOEL over time. On average, the shift is about threefold, which is why some of our public comments yesterday mentioned study hard. You may not have to use a default factor of 10. Another consideration, accumulation, slow elimination or metabolic buildup can increase long-term toxicity. Reversibility, reversible effects may not persist, while progressive effects may worsen. These are all considerations, of course. Study quality, protocol limits, small sample size, or weak pathology reduce confidence in your extrapolation. The default factor of 10, used a lot. I've used it lots of times with different databases. Chemical specific data, sure. Kinetic or long-term studies can justify a different factor. It can go up or it could go down. So those are the kinds of considerations our colleagues at EPA, I'm sure, do this all the time. And the committee would like, if you're using immunotoxicology, you might use a smaller factor on the basis of the 14 and 90-day studies. If it's something other than that, then here's some considerations to consider, or perhaps use the default value of 10. At this point, we don't have a minority opinion, but I will open it up to my colleagues for additions or subtractions.
Okay, Dr. Barranco?
Nothing to add.
Okay, Dr. Thompson?
Nothing to add.
Dr. Ryer-Powder?
No, nothing to add. That was a great summary. Thank you.
Okay, Dr. Klonick?
Nothing to add.
Okay, any other committee members? Dr. Haber?
Yes, very nice summary, Dr. Dorson, on a very complex assessment. I just wanted to add regarding your comment about reversibility, and this is clearly my own comment, not a consensus comment at the moment, that when we're talking about an intermediate POD, that reversibility I would think would matter because exposure is stopping. While for a chronic POD, we're assuming continuous exposure for an entire person's lifetime. And so even if the effect is reversible, it would still be considered adverse. And it looks like you're nodding, Dr. Dorson. I can't quite tell.
Right. No, that's a very good point, Professor Haber. Thank you very much.
Okay, anyone else? Okay, any clarifying questions from EPA?
Andrew Middleton, EPA. No, we do not have any clarifying questions at this point.
Okay. Okay, I think we're at a point where we might could think about taking lunch today. We're a little bit ahead of schedule, and I would suggest we take an hour today since we're kind of ahead. So I guess, Allie, I'll turn it over to you to take us into lunch.
Yes, thank you everybody for your participation. We will now go to lunch, and the contractor will put the timer on 60 minutes. Thank you.
Hello, is Ali or Tamu there?
Hi, Dr. Apte.
Yeah, hi. I was just trying to get a feel for where we are in the process.
I actually stepped away right before they broke for lunch, so I am probably not the best person to answer that.
Okay, no problem. I
This
will
is
wait.
Allison Jenkins. We're at lunch for some
5 more minutes.
5 more minutes.
Yeah.
Okay. And then
So,
we will go ahead.
Yeah, what question are we on? That's what I was.
We're going to start with question 9 after lunch, but that is after the responses from EPA to the clarifying questions that the committee raised yesterday. So we're going to do that first, and then we'll go into charge question 9.
Okay, and did we do 3 in the morning then?
Yes.
Yes, we did.
And that's the only one they did.
No,
We did.
Go ahead, Robin.
I'm I just kind of want to jump in here for a second. We are still streaming, so you may want to either take this into a chat or a phone call.
Oh, okay. Thank you.
Thank you.
It will occur. Could you make me a co-host, please?
Good afternoon. I guess I'm the one starting this afternoon. Again, I'm Allison Jenkins. I'm a toxicologist at the Texas Commission on Environmental Quality and the co-lead. So I'm going to take over for part of this afternoon from Dr. Gentry. First, I wanted to call the roll. So, Dr. Gentry?
I'm
Are you
here.
here? Okay,
I'm here.
thank you. Dr. Apte?
Yeah, I'm here.
Let's see. Dr. Baker?
I'm here.
Thank you. Dr. Barranco?
I'm here.
Thank you. Dr. Burgoon?
Here.
Dr. Chen?
Hi, I'm here.
Hello. Dr. Dorson?
Present.
Dr. Ike?
I'm here. Good afternoon.
Good afternoon. Dr. Fong?
Yes, I'm here.
Mr. Garvey?
Here.
Thank you. Dr. Lee?
I'm here. Good afternoon.
Good afternoon. Dr. Ryer Powder?
I'm here.
Good, thank you. Let's see, Dr. Samal?
I'm here. Thank you.
Thank you. Dr. Shin?
I'm here.
Thank you. Dr. Tansel?
I'm here.
Thank you. Dr. Thompson?
I'm here.
Mr. Wright?
And I'm here.
Thank you. Dr. Haber?
I'm here.
Thank you. Dr. Klonik?
Present.
Dr. Niemeyer?
I'm here.
Thank you. Dr. Osamitz?
Present.
Thank you. So I believe first we are going to go back to the EPA for their responses to some of those clarifying questions that the committee had yesterday on the charge questions. First, I'm going to ask if EPA is ready for their responses now.
Yes, hi, Dr. Jenkins. This is Kathy Denisio, Senior Science Advisor from EPA. We are ready to read in responses to clarifying questions from yesterday. We're going to have one individual per chemical to read in the questions and responses for that chemical. So we'll move through a few people as we work through the questions and responses.
Okay, thank you.
And so we'll pass it to Neria Arentis as our first individual to read in the clarifying questions and responses for 1,2-DCP. 1,2-dichloropropane, sorry.
Thank you, Kathy. This is Neria Arentis, EPA, reading in responses for questions related to 1,2-dichloropropane. The first question was for the non-cancer endpoints, were the BMD models also frequented? And did you do Bayesian modeling? The response, EPA's response is, as described in Appendix B, benchmark dose modeling results for critical endpoints of the draft human health and environmental hazard assessment for 1,2-dichloropropane, EPA did not employ frequentist model averaging or Bayesian modeling approaches for modeling of critical endpoints. Response to the second question, which is, the question is, what was the dosimetric adjustment used for the intermediate RFC? EPA's response, as stated in section 2.3.2.3.1 of the draft human health and environmental hazard assessment for 1,2-dichloropropane, 1,2-dichloropropane displays characteristics of both a category 1 and category 3 gas, given that the chemical causes both systemic and respiratory effects in accordance with EPA's RFC guidance, US EPA 1994. For category 1 effects, analytical exposure concentrations were converted to HECs by applying a regional gas dose ratio, RGDR. For systemic effects, the relative blood-air partition coefficient between the test organism and humans is considered the driving factor underlying relative dosimetry. For rats, the estimated coefficient is greater than for humans. So in accordance with guidance, US EPA 1994 and US EPA 2012, EPA defaults to a relative ratio of 1, and therefore the internal dose is considered equivalent for rodents and humans. No coefficient is available for mice, so a default coefficient of 1 was used for mouse studies. US EPA 1994. The next question, cancer assessment documented RGDR. Why was the 1994 approach used rather than the 2012 guidance? EPA's response. EPA used the RGDR approach based on formal EPA guidance on inhalation dosimetry from 1994's Methods for Derivation of Inhalation Reference Concentrations and Applicability of Inhalation Dosimetry. US EPA 1994, also consistent with EPA's a review of the reference dose and reference concentration processes from 2002, US EPA 2002. The 2012 document that was referenced, Advances in Inhalation Gas Dosimetry for Derivation of a Reference Concentration, RFC, and Use and Risk Assessment, US EPA 2012, summarizes more recent data for dosimetry based on physiological-based pharmacokinetic PBPK models, but it is not EPA guidance and does not include specific approaches to modify existing RGDR approaches.
Thank you for those. I guess let's circle back to the committee to see if there's any clarifications for the committee members that asked those questions or anything further that we need to clear up relative to those answers. I don't see any further questions, so let's go to the next EPA presenter. Thank you.
Andrew Middleton, EPA. I'll be reading in the questions and responses for 112 trichloroethane. For the first question, did EPA consider a joint analysis of the tumors? EPA's response is EPA did perform a joint analysis of liver cancer by combining male and female rodent data sets. However, this did not add further refinement since the cancer slope factors were similar between males and females. The IUR for female and male mice ranges from 0.016 to 0.018 per ppm. Since there was suicide inhibition of metabolism in female mice, the male mouse data were utilized to be protective of both sexes, since the reactive metabolites are the concern for liver toxicity. The dose response for immunotoxicity is steeper for male mice than female mice, supporting that increased metabolism is more toxic to male mice than female mice. There were robust animal numbers in each sex group for the NCI mouse cancer study, 43 to 49 per group, even at the high dose. For the second question, which was cross-species metabolism differences and similarities, is metabolism in the rats/mice more similar to humans? EPA's response is because no human-specific data are available for the metabolism of 1,1,2-trichloroethane, EPA did not quantitatively compare metabolic rates or sensitivity between rodents and humans. Currently, the metabolic pathways for humans are assumed to be similar to those for rodents, particularly because CYP2E1, the main cytochrome P450 enzymes contributing to metabolic activation, is one of the more conserved P450 enzymes and is functionally conserved across species. However, differences in enzyme expressions and activities may result in differences in metabolic rate and extent among species, including between humans and rodents. As shown in Table 3-1 of the draft TBBPA model review for 1,1,2-trichloroethane, there are quantitative differences in metabolic rate constants between rats and mice, even though they share similar metabolic pathways. For question 3, which was clarify the rationale for the dose metrics selected for route-to-route extrapolation for 1,1,2-trichloroethane, is the current selection based on the metabolites being more toxicologically relevant than the parent compound? The response is the MOA for cancer and non-cancer endpoints informed the dose metrics used by the TBBPA model and were selected on relevance for hazard from either the parent or metabolite production. As discussed in the draft TBBPA model review for 1,1,2-trichloroethane and sections 2.2.5 and 2.4.1 of the draft human and environmental hazard assessment for 1,1,2-trichloroethane, the amount of 1,1,2-trichloroethane metabolized in the liver was chosen as the appropriate dose metric for cancer endpoints, given the metabolic activation as MOA and evidence from dose response data in mice. For these reasons, the amount of 1,1,2-trichloroethane metabolized in the liver was also considered as a reasonable dose metric for non-cancer developmental and immunotoxicity endpoints as well. Sapphire Group 2024. For the acute neurotoxicity endpoint, the maximum concentration of the parent 1,1,2-trichloroethane in the brain was signified as the dose metric in the TBBPA model, Sapphire Group 2004, because the MOA involves nerve cell interaction from the parent compound. And that concludes the questions and responses for 1,1,2-trichloroethane.
Great. Thank you again for responding to those questions so quickly. let's go back to the committee and see if there's any clarifications or further discussion on those responses. And I see Dr. Dorson.
Yes, thank you very much for those good responses to my EPA colleagues. I did have one clarifying question. When you said the benchmark doses for the combined male and female NCI mouse liver tumors, were you comparing benchmark doses? I think it was 0.016 and 0.018, or were those the benchmark dose lower limits, please?
Hello, Kathy Denisio, Senior Science Advisor. We are relaying a response from the team that no, these were IURs.
Okay, so they were based on the lower limits. All right, thank you very much.
Thank you.
Any other questions from the committee on those responses? I don't see any. We'll turn it back over to EPA. Thank you.
Hey, good afternoon. This is Ali Shah to the EPA, and I will be reading the question and clarification for trans-1,2-dichloroethylene. The question is, was the 99.9% destruction removal efficiency, DRE, assumption in Table 4-9 of the exposure TSD applied to exposure inside the facility? EPA's response, Table 4-9 of the draft chemistry, fate, release, and exposure assessment for trans-1,2-dichloroethylene provides a summary of modeled environmental releases for the vapor degreasing occupational exposure scenario, OES. Within the footnote of this table, it is noted that a destruction removal efficiency DRE of 99.99% for trans-1,2-dichloroethylene, but that this assumption is only applied to industrial sites. This assumption of 99.99% removal efficiency is not applied to exposures inside the facility and not applicable to worker exposures. The 99.99% removal efficiency is only applicable to environmental air releases out of the SACC from industrial facilities and therefore impacts exposure to the general population. Thank you, and that's the conclusion of comments regarding trans-1,2-dichloroethylene.
Great, thank you so much. Any clarifying questions about that response for trans-1,2-dichloroethylene? I see none, so I'll go back to EPA.
Hello, my name is Jim Brissett, EPA. Responding to comments, clarifications for 441 methyl ethyl iodine bis 2,6-dibromophenol, TBBPA. Comment is, why was TBBPA not determined to be persistent, bioaccumulative, and toxic, PBT, chemical? Our response in section 3.3 of the draft physical, chemical, and fate assessment of TBBPA discusses transformation processes such as photodegradation, hydrolysis, and biodegradation, which informed EPA's determination that TBBPA is not persistent in the environment. A summary of EPA's determination of TBBPA's persistence and bioaccumulation potential is provided in section 4 of the draft physical, chemical, and fate assessment of TBBPA. TBBPA is not likely to bioconcentrate or bioaccumulate in fish and sediment-dwelling organisms. Bioconcentration and bioaccumulation of TBBPA through dietary exposure is limited due to rapid metabolism, fecal egestion, and biotransformation in aquatic organisms as discussed in section 3.6 of draft physical, chemical, and fate assessment of TBBPA. Next question, comment. How were breakdown products considered? Our response, EPA's response. TBBPA is not expected to be persistent under oxygenated conditions, under anaerobic conditions. Both soil and sediment systems show slow, incomplete transformation of TBBPA, driven by reduction dibromination rather than mineralization. With TBBPA being incompletely transformed, persistent dibromination byproducts will be produced. Intermediate byproducts include tribromo biphenyl A, tri-BBPA, dibromo biphenyl A, di-BBPA, and monobromo phenyl A, mono-BBPA, and the terminal degradant biphenyl A, or BPA. BPA was not considered further in the draft risk evaluation of TBBPA because it is not expected to be persistent in the environment and degradation is expected to occur. Overall, BPA has low persistence and low bioaccumulation potential. This finding agrees with European Union's 2003 and 2005 risk assessment report on BPA. Next comment, clarification of systematic review protocol and documentation for TBBPA. EPA's response, the files for systematic review process, data extraction, and data quality evaluation information for TBBPA have been included in the TBBPA docket as the draft systematic review protocol for TBBPA. Draft data extraction information for environmental hazard and human health hazard, animal toxicology, and epidemiology for TBBPA, and the draft data quality evaluation information for human health hazard, animal toxicology for TBBPA. The supplemental systematic review files include detailed information on EPA's data gathering processes, and the data evaluation and extraction documents include information on metrics considered during the study quality evaluation and rating process. And that concludes our clarification of comments.
Great, thank you for that. Now I'll go back to the committee and see if they have any further questions. And I see that Dr. Chen has a question or comment. Go ahead.
Yeah, thank you. Thanks, Dr. Brissett, for the comments, the response to my questions. I guess I was surprised that it was considered not bioaccumulative because the highly ranked citation that you all have, Tao et al. In Table 3.1 in the draft physical chemical blah, blah, blah report and fate assessment report, it has these numbers that are well above 1,000 and the BAF. And then the other one that's by Hu et al. Are really, filter feeders. I'm an ecologist, and the ones that have these very high BAFs are organisms that feed on organic matter in the sediments, and that's, I think, where TBBPA ends up. So I guess I was kind of surprised that it was not considered bioaccumulative with numbers as high as they are from that particular highly ranked study. That was one thing. And I guess the other question about BPA, which you answered, I'm not a chemist, but I did see in the Danish EPA comments or that they were concerned about these transformation products, the DME and MME. And I guess I was sort of taking their lead. I work on another chemical that has lots of transformation products, and they definitely are of concern. So maybe you could just say a little bit more about the other, these methylated forms and how they're not a concern. Yeah, thank you.
So we can go into basically consult with the colleagues and see if any of the more detailed points within the TSD and the RE we can add additional clarification into what's written into the documents as far as why bioaccumulation is not expected, if there's any additional input other than the elimination rate and biotransformation.
Okay, thank you.
Thank you. Are there any other comments or questions from the committee? Not seeing any. We'll go back to EPA. Thank you.
Good afternoon, Jana Corrales, EPA. I will be reading into the record the clarifying questions and responses for ethylene dibromide. First question.
I'm sorry, I just got feedback that in our clean document, a paragraph was missing that would speak to Dr. Chen's last comment.
Great.
Okay, so you can reread it into the record once you're ready, or on a later date or something.
Okay, I mean, I have it in front of me. I can read it now, or I can step back.
I think you should read it now if you're ready.
I think so
Okay.
too. Okay.
Thank
So
you.
this concerns the BAFs that Dr. Chen was asking about and the effects on accumulation and bioconcentration. BAF results, which range from 153 to 1,553 liter per kilogram wet weight, for TBBPA indicate that its accumulation in aquatic organisms is generally low to moderate. Most field studies reported BAF values below regulatory thresholds for bioaccumulative substances, depending on species and environmental conditions. The BAF values are lower than expected based on TBBPA's high log KOW, 4.75 at a pH of 7.53 and 25 degrees Celsius, mainly because many organisms can rapidly metabolize TBBPA through conjugation and debrominization. This metabolic activity significantly reduces internal concentration and limits overall bioaccumulation. TBBPA is not likely to bioconcentrate and bioaccumulate in fish and sediment-dwelling organisms. Bioconcentration and bioaccumulation of TBBPA through dietary exposure is limited due to rapid metabolism, fecal egestion, and biotransformation of aquatic organisms as discussed in section 3.6 of draft physical chemistry and fate assessments of TBBPA. Sorry, that was left out.
Yeah, no, I guess that's good to hear. The numbers don't quite match up with what's in the papers, but since you said it was something like 1,500 when it ranges from like 900 to 5,000. But in the Tao paper, Tao et al. 2016 paper. And that also assumes that it's not continuously emitted or discharged. So in other words, an animal can break it down, right? But it can't, if it's constantly taking it up, it doesn't really matter. Just wanted to clarify that. But again, thank you.
Thank you.
Thank you. Okay, now let's go back to EPA to continue with the next set of clarifying questions. Thank you.
Good afternoon again. Donna Corrales, EPA. I will be reading into the record questions as well as responses to ethylene dibromide. The first question, how does a POD work for a carcinogen that is linear, not threshold carcinogen? EPA's response is the point of departure, or POD, is defined as the dose response point that marks the beginning of a low dose extrapolation. This point can be the lower bound on dose for an estimated incidence of a change in response level for a dose response model, or BMD, or a NOAEL or LOAEL, for an observed incidence or a change in level of response. See https://www.epa.gov/iris/iris-glossary#P. For linear not threshold carcinogens, the linear low dose extrapolation is performed by drawing a straight line between the POD and the control response. The slope of this line is the slope factor if the x-axis is in units of milligrams per kilogram per day, or inhalation unit risk if the x-axis is in units of micrograms per cubic meter. For the purposes of the TBBPA model route-to-route extrapolation, the POD being referred to on slide 147, charge question 18E.I, was the benchmark concentration calculated using the benchmark dose software, or BMDS, and this was extrapolated between species and exposure scenarios from rat to human before converting it into a dermal slope factor. Next question. What was the POD for the occupational scenario? Higher than NIOSH? This question came up twice, on charge question 16 and charge question 19. EPA's response is regarding charge question 16. EPA clarifies that EPA did not derive a toxicity value of 0.43 ppm. The inhalation unit risk, or IUR, has units of per ppm, also known as ppm to the power of -1 or reciprocal ppm. And this cannot be directly numerically compared to a PEL or REL with units of ppm. Next clarifying question was, is there a unit discrepancy between the Wildlife Exposure Factors Handbook and the Draft Hazard Assessment for ethylene dibromide for allometric scaling? That is, for the units where calculations derived in cubic meters per day or cubic meters per hour. And EPA's response is, the published Draft Hazard Assessment for ethylene dibromide reports the units of the inhalation rate for Japanese quail as cubic meters per hour. Table 3-12 in section 3.3.1.2.4 in the Draft Hazard Assessment for ethylene dibromide. The agency has confirmed that the units of the inhalation rate are incorrect. Rather than cubic meters per hour, the units should have been reported as cubic meters per day, in accordance with section 3.5 of the Wildlife Exposure Factors Handbook for non-passerine birds, USCPA 1993b. The units and associated calculations will be corrected between the draft and final hazard assessment for ethylene dibromide. Next question. Is the vapor concentration of ethylene dibromide at 25 degrees Celsius the maximum vapor concentration, and therefore it drops off on either side of 25 degrees Celsius? Were these saturated vapor concentrations used to set boundary values but not used to calculate any toxicity estimates? EPA's response is, as described in the Screening Tool for Inhalation Risk, or STIR, user guide, which is available online at https://www.epa.gov/pesticide-science- and assessing-pesticide-risk/STIR version-10-users-guide-pesticide-inhalation. STIR is a screening tool that estimates inhalation type exposure based on pesticide-specific information, which OPPT is using to primarily estimate an avian inhalation LD50 milligrams per kilogram. The screening tool calculates the theoretical maximum pure product air concentration that at a standard temperature and pressure based on a chemical's vapor pressure and molecular weight for saturated concentrations in milligrams per cubic meter. The model assumes a theoretical maximal pure product air concentration, i.e. saturation at 25 degrees Celsius and 1 atmosphere, as calculated at a height of 6 inches above the ground without vegetation. The temperature of 25 degrees Celsius and atmospheric pressure of 1 atmosphere were chosen because vapor pressures are frequently available under these conditions, but the relevance to the actual environment at the time of environmental release is a source of uncertainty. The saturated vapor concentration is primarily used in a STIR to estimate the maximum 1-hour vapor inhalation dose in milligrams per kilogram, i.e. estimated exposure, and not the adjusted avian inhalation LD50 in milligrams per kilogram. The STIR uses these two values to estimate the ratio of vapor dose to adjusted inhalation LD50 to preliminarily determine whether there may be risk. However, STIR is only being used to estimate the adjusted avian inhalation LD50 for the hazard characterization, which is the topic of charge question 21. Next question. Are there potential errors in calculation input values for the STIR model, particularly the LD50 and LC50s used? EPA's response is, EPA confirms that the LD50s for rats and Japanese quail, which reflect an oral exposure in the table on slide 170 of the slides for the August 2026 SACC EPA technical presentations for TBBPA 12 DCP, 112 TCA, TCE, and EDB, available in docket number EPA-HQ-OPPT-2246-0165 are correct. The LC50 of 2.12 milligrams per liter derived by EPA based on inhalation rat study was also correctly calculated based on mortality data reported in Rowe et al. 1952. Additional details on the derivation of the LC50 can be found in sections 3.3.1.1.1, 3.3.1.1.2, 3.3.1.2.1, and 3.3.1.2.4 in the draft hazard assessment of ethylene dibromide. Last question. How is body weight factored in as an input parameter and or as an output of a STIR? EPA's response is, EPA confirms that the mean body weight of Japanese quail reported by Westlake et al. 1981 is 0.0786 kilograms, which was used as an input parameter in a STIR. The adjusted avian inhalation LD50 milligrams per kilogram is then scaled to a 0.20 kilogram per. The equation used in this allometric scaling to estimate the adjusted avian inhalation LD50 is described in the STIR user guide, which is available online at https://www.epa.gov/pesticide-science- and assessing pesticide risks /STIR version 10 users guide pesticide inhalation. And this concludes the clarifying questions and responses for today. Thank you.
Great, thank you for all of those clarifications. I'm going to open it up to the committee to see if there's any questions on those or any additional information is needed from EPA. And did you say that concluded the information from EPA for today? I think so. Okay, I see a question. Dr. Lee, go ahead.
Okay, so this is Lee, a SACC member. So thank you so much for confirming the use of incorrect unit for the inhalation rate of Japanese quail. So since this number was used to calculate LC50 and other quantities in the later calculations, I was wondering whether EPA would like to provide us new or updated calculate results, and we comment on that, or we first provide our comments on the current results and the EPA will revisit the calculation later.
Thank you for the question. EPA will be doing those calculations between draft and final hazard assessment for EDB, ethylene dibromide, sorry.
Okay, so that means we will go ahead and provide our written comments like before. Okay, yeah, thank you so much.
Thank you.
Were there any other questions from the committee on ethylene dibromide or any of the others? And I wanted to make sure there are no other responses from EPA that we need to go over. Is that correct?
That is correct.
Okay, thank you. Okay, with that, no other questions from the committee either. We're going to move on to charge question 9. And then after 9, we're going to go to charge question 21. So charge questions 9A to 9C, and that's on 1,1,2-trichloroethane. As before, the introductory information is on the screen and in the agenda and public docket. Please read through this, and then EPA will read charge question 9A into the record. Thank you.
Andrew Middleton, EPA, reading in question 9A. Please comment on EPA's evaluation of the laboratory animal data in section 2.4.1. Please include in your comments a consideration of the data quality ratings derived from the US EPA 2026B for the laboratory animal cancer bioassay for 1,1,2-trichloroethane. NCI 1978.
Thank you for getting that into the record. And now we will turn to our lead discussant for this charge question, and that's Dr. Chad Thompson. Dr. Thompson?
Okay, so the committee agrees with EPA's evaluation of the animal cancer data. EPA has identified the strengths and uncertainties of the available database. The NCI 1978 study provides the strongest evidence for carcinogenicity of 1,1,2-trichloroethane in experimental animals. It correctly identified the mouse tumors rather than rat tumors as the drivers of carcinogenicity. The NCI study used both sexes of 2 rodent species, chronic repeated exposures, and concurrent control groups. In addition, histopathological examinations were done in multiple tissues and showed clear dose-related liver tumor responses in mice. In addition, the dose-dependent increase in liver tumor, there was a dose-dependent increase in liver tumor incidence in mice. Further supporting this finding was the enhanced temporality of tumor formation, noted as a dose-dependent decrease in the days to first observation of liver tumor in the low and high dose groups, particularly in male mice. This is, there was general agreement on the medium study quality score. However, it must be acknowledged that the NCI study predates OECD and EPA carcinogenicity testing guidelines, and therefore does not meet current study guidelines. Some particular shortcomings are listed here. The use of only 2 treatment groups with relatively narrow dose spacing, a low N in the negative control group, metric 7, which is preparation and storage of test substance, does not include mention of dose formulation analysis, and a review of the study confirmed that there was no mention of whether the dose formulation was analyzed analytically. The 78-week exposure duration is shorter than the current carcinogenicity testing guidelines of approximately 104 weeks, and the shorter duration could potentially miss some late developing tumors. Mechanistic information is limited from these early studies since investigators were mostly concerned with whether the chemical was causing cancer and less concerned about non-neoplastic lesions or gaining mechanistic insight to inform potential MOAs. Notwithstanding these above shortcomings, the NCI chronic study was performed as state-of-the-art at the time. The results are well defined and correctly analyzed statistically. The induction of mouse liver tumors is seen at 2 high doses in both genders. No liver tumors were seen in treated rats, and this pattern is consistent with many chlorinated compounds that have been examined in the chronic 2-year cancer bioassay, including dieldrin and trichloroethylene. A more fundamental concern is that the NCI study, because it was a gavage dosing study, that this will lead to high peak concentrations of Cmax in contrast to drinking water exposures. Given the high volatility, the rapid absorption, and the extensive metabolism of 1,1,2-trichloroethane, bolus dosing is likely to result in internal dose profiles that differ significantly from environmentally relevant oral exposures through drinking water or food. The public did comment and ask the SACC to consider this issue in the NCI study, that these oral gavage dosings would provide different internal metrics than typical human exposure. And while we are not aware of any provision to discard these data, the committee does recommend that EPA potentially use the PBK model that's already available in mouse and that is being used to extrapolate from oral to inhalation doses to consider whether there's something that could be done to better estimate what the exposures or match oral exposures to these kinetics from the bolus dosing. And so the recommendation here, while we agree with the use of the study, that EPA should further consider how to account for the gavage dosing issue and its disparity between the expected human exposures, and whether the existing mouse PBK model could be used to assist in that process.
Great. Thank you for that nice summary. Now I'm going to go to the associate discussants to see if they have any other comments or additions. Dr. Abdi?
I don't have any additional comments. My comments were captured. Thank you. Very nice summary.
Thank you. Dr. Dorson?
Okay. Thank you, Dr. Thompson, for a nice summary. 2 small points. These are just additions. First of all, we'll find in many of the EPA's tables an unacceptable level of precision. This is sort of a cross-cutting comment. So just tighten them up, please. On page 148 of the document, there seems to be a mistake. The visual fit for the multi-stage model does not work well. If you look at the table ahead of that, they were calling out the multi-stage 2 model as failing. But if you look at the visual fit, which I believe is on page 149 or 149, the visual fit is perfect. So the minor point here is please check visual fits on your model runs, because sometimes, that's, visual fit, residuals, and p-value are the first things you should always check. It's just a check. I think it was just a glitch in the mathematical modeling there. Minor point. I really appreciate the answers to the questions on rats versus mice. You know, how are humans different? Because that makes a difference in which tumor set you might likely model. EPA, you know, again, recommends the species we choose is the one that most resembles people. I mean, people first, species that most resembles people next, and of course, the most sensitive species, which is often where we end up, third. So that was why the question was there, and thank you for the answer. The thing that, the large thing here that was somewhat bothersome is probably not the right word. It was surprising is we have a lot of, this is a solvent after all, we have a lot of cell killing, a lot of regeneration. You certainly see it in the early studies, in the short-term studies. You don't see this regeneration in the NCI bioassay because honestly, they didn't look for it. And when we did a review of 1,4-dioxane, a 1978 NCI study, the slides were restained and Gene McConnell read them. And I think I've submitted the report to the file here. There was non-cancer toxicity all over the place. And so it builds the idea of a mode of action that's hyperplasia regeneration mode of action. I think our colleagues of EPA should consider that. And I think they should consider it in part because EPA's guidelines leads us to that. You know, the 2005 guidelines, of course, are quite good. They, of course, are a little bit old now. And Gina Hilton yesterday talked about, you know, from PETA talked about maybe it's time for EPA to kind of redo the guidelines and put in some new NAM work. And I know a couple administrations ago, there was an effort to do that. I think it's probably a good effort to do it. You know, maybe relook at the guidelines. But the guidelines are very clear. If you go to page 3-21, you know, when to use linear non-threshold model. There's two qualifications. Well, actually, there's three. If you've got data that suggests linear, like mutations, you know, mutation is a key event, the first key event, then it makes sense. But when the weight of evidence of all available data are insufficient to establish a mode of action for tumor site, and I would argue that with all your negative data, negative mutation data, that you don't have a basis for a mutagenic mode of action. So the guidelines go on to say, you know, when the data are insufficient to establish a mode of action for a tumor site, and this is the critical part, and when scientifically plausible based on the available data, linear extrapolation is used as a default. Well, in the case of 1,1,1-trichloroethane, the data are not scientifically plausible that linear is appropriate. In fact, you've got negative mutation data. So I think our EPA colleagues need to contrast the mode of action for mutagenic mode of action, which they've done, and emphasize the negative mutation data. And then I would also build a mode of action for regenerative hyperplasia. I will, you know, defer to Professor Klonik and others that are steeped in knowledge on cancer mechanisms to kind of weigh in on this. I would suggest you do both. And if you truly come to a point where you've got two modes of action that you semi-real, or then you can go to EPA page 322 and do a dual mode of action analysis. You know, the EPA guidelines are very good this way, and I would encourage our colleagues to do that. Thank you.
Thank you. The next associate discussant, Dr. Barranco. Any other comments? None to add. Okay, thank you. Dr. Klonig.
Okay, thank you. I do have some comments. First of all, I agree with Dr. Dorson. I think that in this document, they could do a much better job, at least proposing mode of action. And we know from other chlorinated compounds that many that I've worked with that it's actually CAR activation. But then you also have chlorinated compounds like carbon tetrachloroform that are actually what Dr. Dorson mentioned, which are cytotoxic, induce necrosis and regenerative hyperplasia. So there could be more emphasis or more looking in the document or make some proposing to come up with a mode of action. The NCI mouse study was I guess state of the art for the time, 1978. Unfortunately, it has a lot of holes in it. But we need to work through that, I guess. And with regard to the EPA's, the documents review of that study, I agree that the mouse liver tumors are positive. They showed a positive response. There is a dose response characteristic there. And the preliminary or the previous studies on genotoxicity or mutagenicity are, for the most part, negative. And so therefore I would say this is working through a non-genotoxic threshold dependent mechanism in the mouse liver. The rat liver data is interesting because the document, and I'm going to read from on line 2575 of the document, says overall qualitative 1,1,2 trichloroethane caused multiple tumors in 2 species, mouse and rat. But then it goes on to basically say the mouse study was rated medium quality under EPA's systematic review process. The rat study had several limitations, but still found tumors, although they're not statistically significant. So I can just think of Joe Hazeman reading that and clutching his heart, basically. I mean, they're not statistically significant, therefore they're not positive. Along those same lines, the document, the EPA document, settled on this Millman paper, which was basically a mechanistic paper looking at possible 2-stage carcinogenesis using this model that Henry Pito put together, and we actually adapted it for the mouse later on, where you initiate with a diethylnitrosamine and promote with phenobarbital or whatever your compound was. Now, the authors of that paper basically state that they did not believe there was some suggestion that 1,1,2 trichloroethane was actually a complete carcinogen, but the authors stated no. They said basically they said no, and that the reason that they saw a slight increase in quote initiation activity was probably due to cytotoxicity and the high dose that they use. I would like to make some comments regarding that, though, that and the EPA document kind of settled on this SAFR group 2004B paper for their PBK modeling, but also on the consensus on this rat liver tumor effect. And what I want to bring out is that they both the document and the SAFR group missed the original paper that the Millman authors listed, and that's a story paper that was published 2 years before, and I can provide that reference, but that was missed, and basically showed the same data and came to the same conclusions. So therefore, my conclusion basically is that this is a mouse liver tumor induction in liver tumors. They did see an increase in pheochromocytomas, which is unusual for the mouse. It's usually seen in the rat, but it was there and it was significant. That the rat study was, I would argue, you can't use it at all, the chronic rat study, because of the severe limitations. And but I would not say you found tumors in multiple tissues and not statistically significant. A couple of other comments, and I don't want to be too strict on this, but throughout the document they're talking about adrenal tumors. And as a pathologist, what we wanted, what should be said is either call them pheochromocytomas or call them adrenal medullary tumors. We all know that the adrenal gland contains both medullary and cortex components. The cortex, of course, is epinephrine, ADH, and so on, while the medulla is a neurotumor, is a neuro component. And so we need to be clear that there's a difference in this, and I would argue that the document needs to clarify either calling them adrenal medullary tumors or actually call them pheochromocytomas. That's all I have. Thank you.
Great, thank you. Dr. Haber, any further comments on 9A?
Yes, I have a question and some comments. So my first question is probably primarily to Dr. Clonig, although others may wish to weigh in. So we often talk about the B6C3F1 mouse being particularly susceptible to liver tumors. But in this study, the control incidence was 0 for both males and female mice. So I was wondering if you could comment on that. Was this study basically before the strain developed that particular sensitivity, or what are your thoughts?
You hit the nail on the head, because I did, I hate to admit it, I did work back in 1978, 76, and so on, and the spontaneous tumor rate was much lower. Now it's approaching, in the male B6E3 mouse, it's 30%, 40%. 0 is kind of interesting because we always used to see some tumors in the male. The female was much lower. In fact, I don't want to get into it. A large discussion on this, but usually you can tell the compound that it causes a greater effect in the female because the control spontaneous tumor rate in the female is much lower. But I think we're dealing with the B6E3F1 that was before we fed them real well, before the husbandry selected out sensitivity and so on. So it surprised me that there were no tumors, but in the same regard, I would expect the lower tumors, but I think the assay for the mouse was run properly.
Great, thank you. And my comment relates to the genotoxicity data. So a general comment on the way that the data are presented is that for most of these studies, based solely on the summary tables without digging into the studies themselves, as an independent reviewer, I cannot tell whether the tests were done to adequately high doses according to test guidelines. So thank you for providing information on the dose levels, but given this is not a super toxic chemical, we don't know if even several hundred milligrams per kilogram in a single dose, whether that was sufficiently toxic, again, to meet test guidelines. And so this relates to both the in vivo assays and then also the in vitro assays. There are numerous bacterial tests, many of which say that the doses weren't even reported. So the way I was trained is that these would be called a no test because we cannot evaluate it even if you look at the original data. So I think it's very important to make sure that we're looking at the entire weight of evidence regarding genotoxicity, not just counting positives and negatives. I did also want to note that there were some positive results for the micronucleus assay, which is one of the standard bioassays, although not in the in vitro, I will note. But there were positives for micronuclei in human cells. Yeah, so I'll just stop there and note that there's both additional documentation needed, and I would suggest additional evaluation of the weight of evidence of the mode of action. That said, I would also strongly support looking at alternative modes of action, and in particular, using the Meek et al. 2014 paper on the evolved Bradford Hill considerations to do a comparative weight of evidence evaluation of mutagenicity and other hypothesized modes of action.
Thank you, Dr. Haber. Did that conclude your comments?
Yes, that did.
Okay, Dr. Dorson?
Yeah, Professor Haber, thank you very much for bringing that up. Understanding the doses associated with the gene tox and mutagenicity would be really important because it directly affects kind of what I had said before. You were part or participated in the public meeting for the US EPA guidelines 2007 on mutagenicity. And my take-home message from that, and of course this is just the take-home, was you can have a lot of genotoxicity, that's great, and it's good to record that. But just because you have genotoxicity doesn't mean you have a mutagenic mode of action, because you need mutations as early key events before you can start to hypothesize that mode of action. Do you see EPA referring to these mutagenicity guidelines? I know there's probably still draft, but would that
They are
weigh
still
in and help
draft.
them? Would that help our colleagues in understanding and weighing through this mutagenicity data for purposes of going linear or not? That's, question.
Lynn Haber, SACC. You are correct that those guidelines are still draft. They were further enhanced in a recent paper by Martha Moore and colleagues, which I admit I was a co-author on, that was published about 2023, I think. So yes, that would enhance things. And the reality is that the data to fully address whether the chemical is not just mutagenic, but whether it's causing cancer via a mutagenic mode of action is very rarely present, because we don't have the in vivo or other mechanistic data to fully address that. So I think that's a very high bar to evaluate mutagenicity. But I think there is more that could be done for comparative weight of evidence.
Thank you.
Dr. Klonig, did you have your hand up, or?
Yeah, just a side note, and Dr. Haber, when she brought up about the spontaneous tumors, I forgot, if you notice, anybody that's read any bioassays that's come out in the last 20 years, when we look at liver tumors, we always talk about focal lesions, we talk about adenomas, talk about carcinomas, and sometimes we talk about blastomas, and other liver tumor types. You notice in this NCI paper with the mice, they only talk about adenocarcinomas, because the classification at that time was not well established in the mouse. It was in the rat, but not in the mouse with regard to the classification of adenomas, foci, and adenocarcinoma. So it was considered a carcinoma by default. I just wanted to bring that up.
Great, thank you. Are there any other comments from the rest of the committee on 9A? I am not seeing any. So I think I go to EPA now to see if they have any clarifying or questions or would like more information about 9A.
Andrew Middleton, EPA. We do not have any clarifying questions at this time.
Okay, great. So let's go to 9B, if maybe that one is posted. If everybody could read the charge question, and then after 30 seconds or so, if EPA could read the charge into the record. Thank you.
Andrew Middleton, EPA, reading in charge question 9B. Please comment on the strengths and characterization of uncertainties related to EPA's preliminary cancer classification for 1,1,2-trichloroethane.
Thank you. Okay, let's go to the lead discussant for this one. Again, Dr. Chad Thompson. Thanks.
Okay, so the committee felt that the NCI studies identified the occurrence of hepatocellular tumors in both sexes of mice. The liver tumor data demonstrated a clear exposure-response relationship, with the liver tumor incidences increasing with dose and with consistency between the sexes. The consistency supports a causal association between the exposure and the tumor development, and the observation of the pheochromocytomas in the mice adds some support to the carcinogenic potential of 1,1,2-trichloroethane. However, the committee has not yet reached a consensus on EPA's cancer classification. Considering that the cancer promotion assays are not direct evidence of carcinogenicity, the Millman et al. 1988 study does not, there's some debate about whether that provides the necessary evidence for carcinogenicity. Although this promoter study indicates that 1,1,2-trichloroethane has the potential to enhance liver tumor development, it is not a complete carcinogen and can only support and not drive overall cancer classification. There'll be more on that paper in a moment. Considering that none of the tumors in the rat study were statistically significant, these tumors could not contribute to the classification. In fact, if you go to the NTP website, the cancer results in rats are listed as negative, and we provide the website for that. IARC 1999 has listed 1,1,2-trichloroethane as category 3, not classifiable as to carcinogenicity in humans. As there appears to be no new animal cancer data since 1999, the evidence appears more uncertain than proposed by EPA. As such, there is only evidence of carcinogenicity in one study, as discussed in the 2005 cancer guidelines for carcinogen risk assessment. For the descriptor suggestive evidence of carcinogenic potential, the descriptor of the database is appropriate when the weight of evidence is suggestive of carcinogenicity. A concern for potential carcinogenic effects in humans is raised, but the data are judged not sufficient for a stronger conclusion. The descriptor covers a spectrum of evidence associated with varying levels of concern for carcinogenicity, ranging from a positive result in the only study on the agent to a single positive cancer result in an extensive database that includes negative studies in other species. Several committee members concluded that based on that guidance, the IARC determination, the inconsistency in the genotoxicity data, and the absence of any epidemiological support for carcinogenicity, that a suggestive evidence of carcinogenic potential seems more appropriate than likely carcinogenic to humans. Other committee members agreed that with the agency on the assignment of likely carcinogenic to humans based on the criteria included in the cancer guidelines. As stated in the guidelines, some of the criteria which support the designation were noted in the mouse carcinogenicity study, including testing positive in animal experiment in more than one sex, so the liver tumors were in both sexes, a positive tumor response and high degree of malignancy and early age of onset, and the rare tumor response of the pheochromocytomas in mice, where I think they're more common in the rat. One member stated that the strong genotoxicity data and the mouse data from the NCI study and the GSDP positive data from the Millman study, that the designation of likely carcinogenic to humans was justified. They went on to say that this is further supported by Cal EPA's independent assessment. California OHIA's independent 2006 assessment reached a broadly similar conclusion. However, the quote is, should be treated as a potential human carcinogen from the same core data set, providing some independent non-EPA corroboration, though OHIA's own, in quotes, potential language again reads more hedged than EPA's proposed likely. Quantitative concordance, tumors at 2 sites, 2 sexes, and 1 species with a strong within study dose response is a legitimate basis for concern and is fairly characterized in EPA's document. Some minor uncertainties that come from basing an entire risk assessment on 1 or 2 studies that are decades old could be an issue. Further, and then again, they mentioned that the IARC has not had any change to their position that it is a category 3 in the last 20 years. So there are some caveats there. Some committee members provided additional comments on the Millman et al. Study, and I think we'll hear some of that after my remarks here. The Millman 1988 study showed that 1,1,2 trichloroethane is positive for eliciting DNA repair response in hepatocytes derived from Osborne Mendel rats. The B6C3F1 mice were not tested, which suggested genotoxicity activity. This finding conflicts with the liver tumors not being observed in rats of the same strain in the CARC study. Also, the Millman et al. 1988 study was positive in the rats for increasing enzyme-altered liver foci in the tumor promotion protocol, which again, if having occurred in the cancer study in the same strain of rats, failed to elicit the formation of the liver tumors. In conclusion, some of the committee members did not view the findings of Millman et al. As useful for hypothesizing that 1,1,2 trichloroethane acts as a tumor initiator promoter or a genotoxicant in the liver, as there was no corresponding liver tumor observed in the rat cancer bioassay. In fact, the study authors of Millman et al. Stated that the study results were neither sufficient nor definitive for supporting the carcinogenic mechanisms of 1,1,2 trichloroethane. I guess the recommendation here, just for currently, we're still seeking consensus on the EPA cancer classification.
Great, thank you for that summary of responses on 9B. Now it's the same associate discussants for 9B, so I'll start off with Dr. Apte, if you have anything else to add.
Yeah, this is Udayan Apte, SACC. My comments were all included. I just have, I'm going to make 2 comments that are in general, and I think this is good place as any other. This is related to Millman et al. Study. I think it's a good idea to include a result of the GSTP positive foci from the Millman et al. Study into the document. A lot of stuff depends on that finding, so it's a good idea to have it. And I strongly recommend EPA to redraw the metabolism scheme, figure 212, which essentially somebody copied and pasted from a pre-computer era and took some time to read. So for a purpose of clarity and beautification of the document, I strongly recommend they redraw it. Thank you.
Thank you. Dr. Dorson.
Yeah, yeah, thank you. I appreciate Chad's or Dr. Thompson's summary, and I very much like Professor Klonig's talk about the Millman study, points of which I was unaware. But I think Chad did a good job of summarizing things, and that's enough for me now.
Thank you. Dr. Barranco, any additional comments?
No, Chad summarized well.
Great, thank you. Dr. Klonig, anything else for this one?
No, I have no more comments. Dr. Thompson did an excellent job. I thought excellent summary.
Great, thank you. Dr. Haber, any additional comments on 9B?
I agree that Dr. Thompson did a great job of capturing the range of opinions. I have a process question. I assume that questions to other subgroup members related to reaching consensus should be handled offline rather than here. Is that correct?
Yes, that's correct. Mm-hmm.
So I have nothing further.
I believe that's correct. Dr. Gentry, if you want to step in, I think it is correct.
It is correct.
Yes, it is
Okay,
correct.
thank you. Thank you. So now I'm going to go to the rest of the committee. If there are any other comments, additions to 9.
B.
Anything else? No. If not, I'm going to go to EPA and see if there's any clarifying questions or additional information needed from the committee.
Yeah, hi everyone, Anna Lowett, Senior Science Advisor. I do have a question for Dr. Thompson. So first, thank you for that very clear explanation and that long, lengthy description. It was very easy to follow. I did have a question about your phrasing around the lack of consensus, or maybe you're still working on consensus about the cancer classification. Just a couple things. If there's not 100% agreement, it's perfectly fine as long as the report reflects a sense of the balance, you know, a minority opinion, a majority opinion, an equal or something like that, or a single person. As long as the report is an accurate reflection of the comments. If you don't come to 100% agreement, that's perfectly fine. But my question, so that's just a point to make sure that that's clear, but I was a little bit uncertain where you are right now, because I heard you say that some members believe that classification should be suggestive, and others thought likely, and then a couple sentences later you said one person thought it should be likely. And is that what y'all are still working on right now? Because that's an important distinction with regards to the dose response. For a suggestive classification, we would not do linear extrapolation and normal proceedings.
Yes. So my recollection right now is it is one person with the exception of possibly our what do we call her adjunct member, Lynn, Dr. Haber. So I can't speak for her at the moment, but right now it seems to be a minority opinion that it should remain as likely. But we are, like I said, going to try to reach consensus, and if we can't, we will note the spread.
Thank you for that. Does EPA have any other comments?
Yeah, so if the committee does come to consensus, does that mean later in the week that question 9B will circle back for public discussion? Just making sure we understand what the process and the steps are.
That is my understanding. Like with some of the other questions, we're going to circle back. So I think we could do that with 9B also. We'll put that on the list to circle back to. Okay, without any other comments, we'll go to 9C. If EPA could post the question and give everybody a minute or so to read through that and then read the bolded charge into the record. Thank you.
Andrew Middleton, EPA. I'm reading in charge question 9C. Please comment on the strength and characterization of uncertainties relevant to the 1,1,2-trichloroethane mode of action analysis, oral/dermal cancer slope factor, and inhalation unit risk derivations, and the selection of default linear low dose extrapolation approach.
Thanks, Dr. Middleton. I appreciate it. We'll go to Dr. Thompson again as the lead discussant for 9C. Thanks.
Okay, so like the previous one, the committee has not yet reached full consensus on the use of linear low-dose extrapolation. Since no mode of action for 1,1,2-trichloroethane-induced liver tumors was put forward by EPA, one could argue that a linear low-dose extrapolation approach based on an unknown mode of action, as suggested by the cancer guidelines, is obviously it's technically consistent with those guidelines. However, given that the mixed genotoxicity findings in Table 223 and the mostly older non-OECD, or in some cases withdrawn OECD guideline assays, the SACC agrees with EPA's decision to not include any ADFs. So there's definitely no clear indication of a mutagenic mode of action. The hypothesis that direct-acting genotoxic effects and metabolites might act as the molecular initiating event, the committee believes is premature, given the lack of tumors observed in chronically dosed rats, despite the study showing potential genotoxicity via the tumor initiation promotion activity in the Millman study. And the lack of in vivo micronucleus formation, despite in vitro positive assays, and nearly all bacteria-based assays testing negative for mutagenic effects. The committee nevertheless appreciated that the remaining genotoxicity assays, which were positive, such as DNA synthesis, repair, adduct formation, indirectly suggest potential genotoxic events occurring. However, many of these indirect measures, and some have OECD test guidelines that have been withdrawn, or again, they're indirect indicators of genotoxicity. One committee member commented that the lack of determination of a validated nonlinear or threshold mode of action that makes defaulting to linear low-dose extrapolation consistent with the guidelines. I think I mentioned that. And as a choice reasonably supported by what was characterized as strongly linear apparent dose response in the cancer bioassay. EPA's decision to use male rather than female mouse BMDL, specifically because the PBK model indicates suicide inhibition of metabolism in female mice, which would otherwise underestimate the risk by using the metabolically atypical data set, is transparent and appropriately conservative modeling choice. The underlying Sapphire Group PBK model also has a long track record for chemical-specific model, having informed EPA's 1987 and 2011 assessments and Cal EPA's 2006 assessment over more than 2 decades, which provides some institutional continuity, if not an independent validation. See below, we'll come back to that. Other committee members argued that under EPA's 2005 cancer guidelines, linear low-dose extrapolation is recommended when supported by biology, when the dose-response curve is expected to be linear below the pod, or when the mode of action for a tumor site has not been established and data suggests linear plausibility. The data set for 1,1,2-trichloroethane indicates does not clearly support linearity based on the available genotoxicity data, as I mentioned, is inconsistent, and therefore a default low-dose linear extrapolation is not warranted, or at least it should be considered along with data that support a nonlinear mode of action. For example, pharmacokinetics show that rats and mice metabolize 1,1,2-trichloroethane differently, and this is likely responsible for the differences in the tumor response. And a question raised here is, do we know whether humans, their metabolic profile is more similar to rats or mice? It's an important question that EPA needs to address. EPA should also explore other modes of action, such as regenerative hyperplasia, that, by the way, has already been mentioned, which has already been demonstrated with other chemistries, similar chemistries. Please take note that early NCI studies routinely did not look for non-cancer toxicity. And so there, unfortunately, some of those studies don't provide great information that could potentially be reanalyzed, or look for shorter term studies to see any signs, or have slides reread to potentially look for these preneoplastic lesions. One committee member noted that the pattern of liver tumors by 1,1,2-trichloroethane is very similar to those in other chlorinated compounds, where only the mouse liver shows the tumor response. And in addition, the study by Millman et al. 1988, is it 88 or 98, demonstrates a tumor promoter type of mechanism, and therefore the compound is non-genotoxic and only shows tumors in one species that should be characterized as dose-dependent but non-genotoxic and non-linear. Several committee members commented on the BMD modeling. One member commented that EPA should revisit the benchmark dose modeling results and focus on visual fit, as we heard earlier. For example, EPA Appendix 2B notes that the multi-stage model failed. However, the visual fits were strong. Use of the multi-stage 2 model, the committee member recommended using the multi-stage 2 model. Another committee member noted that the model output in Appendix 2B does not include all of the BMDS model recommendations and warnings that you typically get with the full suite. For some reason, the BMDS provides less information when you're modeling cancer data. But as we will be showing in our written report, the MS1 model is labeled as questionable. In contrast, there are other models, such as Logistic, that has a much lower AIC than the multi-stage model. And though we understand that EPA often uses the multi-stage cancer model for developing cancer slope factor, we do not think that the nonlinear dose response model precludes deriving a cancer slope factor. The important aspect is to fit the data. With regard to route extrapolation, so we're talking oral to dermal here, the committee advised the agency to consider whether the orally dosed study eliciting liver tumor effects is appropriate for extrapolation via the inhalation route, given the presumed enhanced liver exposure via the portal vein following ingestion of the chemical versus the what it would be expected following inhalation. And sorry, that was with regard to inhalation. With regard to the dermal extrapolation, there was, given the low dermal absorption noted in the report with regard to human skin, relative to the animal PBK model studies using the dosing orally, again, the low dermal absorption should be considered in this extrapolation. Let's see. The committee also had comments on the PBK model. The Sapphire Group PBK model underlying the inhalation unit risk derivation was developed in 2002 under an industry-funded enforceable consent agreement, and EPA's own 2006 guidance on PBK model application and risk assessment calls for case-by-case evaluations of structural validity, independent calibration, and dose metric justification rather than blanket acceptance of existing models. It is important to consider whether this specific model has undergone independent validation by parties other than its original developer at any point in the past 2 decades, particularly since it's now being used to support the materially different and stronger quantitative and classificatory outcome than it supported previously, moving the inhalation value from a simple default oral to inhalation route conversion under the legacy IRIS assessment to full PBK model-based extrapolation. EPA identifies but does not fully resolve some dose metric limitations. The PBK model predicted internal dose metrics for cytochrome P450 mediated hepatic metabolism, shows deviations from linearity at the highest tested dose, even as the tumor response itself increase roughly linear with administered dose, a pattern EPA attributes to quote unquote complex dynamic cancer biology involving multiple reactive metabolites, glutathione conjugation, and aldehyde dehydrogenase 2 mediated clearance of the 2-chloroacid-aldehyde metabolites. The document states that the chosen metric does not capture the complexity of the mode of action, and that the chemical species to which tumor formation is most important is not separately quantified in the PBK model. EPA further flags appropriately that decreased ALDH2 clearance activity, a polymorphism carried by several million Americans, could plausibly increase susceptibility to 2-chloroacid-aldehyde metabolites, but notes no 1,12-trichloroethane toxicology data exist in ALDH2 deficient animal models to evaluate this. If a sensitivity analysis is conducted using ALDH2 using an ALDH2 informed internal dose metric rather than the total CYP-mediated metabolism alone, would that materially change the derived slope factor or inhalation unit risk? Further, the ALDH2 polymorphism should be addressed as a potential susceptible population in the broader risk characterization. So I know there's a lot of topics covered here. So here are a few of the recommendations with regard to mode of action. In light of the weak and negative genotoxicity data, EPA should conduct a rigorous evaluation of the mutagenicity and potential alternative modes of action using the evolved Bradford-Hill considerations and comparative weight of evidence framework, such as Meek et al. 2014. Linear extrapolation, EPA should consider nonlinear approaches for cancer, including the use of precursor lesions, if available. And EPA should reevaluate the selection of the multistage 1 model for deriving the oral cancer slope factor. In general, the model should be done with at least the multi-stage degree set to N-1 rather than only using MS1 model. Ideally, all of the models could be used. Transparency would enhance and clarify identifying the endpoint being modeled for each. Transparency would be enhanced by clearly identifying the endpoint being modeled. I think this is a comment on the actual presentation in the appendices, where we're saying here that the transparency would be enhanced by clearly identifying the endpoint that is being modeled as you go through presenting each of the BMD modeling outputs. With regard to route extrapolation, the committee suggests that there be more accounting for the low dermal absorption in the derivation of the dermal cancer slope factor. Let's see. In addition, clarify how and if EPA evaluated the PPK model and assess potential influences of ALDH2 polymorphisms. And again, I think with regard to, we could also, I think we mentioned previously, using the PBK model to potentially address the gavage dosing issues. I'll stop now.
Great. That was a lot of information that you summarized. Thanks for that. So anything else, Dr. Apte?
That was a phenomenal job by Dr. Thompson. I just want to add one thing to the growing list of things, I guess, as a recommendation, but we do this. I've been doing this for the last few SACC meetings because I want to reiterate this point, and it's important. One, the chemical TCE that we're looking at, and several others in this SACC meeting, are fat soluble. About 40% of Americans are either obese or overweight. A lot of people are now taking GLP-1 drugs that mobilize fat. That has a major bearing on your internal dosimetry and your exposure. The fat content, I mean, if you look at where the chemical will distribute after it's absorbed, is going to go to the fat first and stay there, and when it mobilize it's going to come out. And I think it's it's critical for EPA to start thinking about it when they do risk assessments. As stated right now, PESS does not include people with obesity, but that is something that needs to be considered. And the first place they could be starting is PBPK modeling, which is where this can be done with a relatively less time and stress as accepted by EPA staff themselves in the last SACC meeting. And so I just wanted to make that point again, that using fat content, body fat content, obesity as a consideration is important as we go, which is directly related to about 40% of Americans. Thank you.
Thank you, Dr. Apte, for that. Dr. Dorson, anything else to add?
Yeah,
for 9C?
yeah, Dr. Thompson, wonderful summary. It was amazing. Just one thing to add, and I know my EPA colleagues are not looking for research, but if it's important to you and somehow your deadline slips, rereading the slides from 1978, they'll probably have to be restained, but NCI did that for us for 1,4-dioxane. I think you can get that all done in 3 months if it's important. And again, if your deadline slips. Thank you.
Thank you. Dr. Barranco?
I have nothing to add. Thank you.
Thanks. Dr. Klonick, anything to add?
I'll just echo what Michael just mentioned. I think that is a great idea, and I think these slides are held by in an archive, so I think that's certainly doable and would tell a lot of information on this. One question I have for my modeling friends is, how come we didn't look at the pheochromocytoma, which is only seen in the mouse at the high dose? So we actually have a quote threshold. We have a dose that did not produce pheochromocytomas, and a high dose did. Why was that not considered? I'm just curious. I don't know the answer.
Well, I don't know if Lynn wants to weigh in, or this is to EPA or us. My guess is that generally it's difficult to model things when you only have a response at one dose and the top dose. So that might have been one reason.
And a question back to you, Professor Klonick. I had understood, perhaps incorrectly, that these tumors, these adrenal tumors, are also stress related, and therefore, it's not always appropriate to model them because of that. Or am I misremembering something?
I think you may be thinking of the cortical tumors.
Oh.
I might be wrong on that. I just looked real quick, mode of action, pheochromocytomas in rodents, and there was no mode of action given. So I was just curious, but I think Chad's answer is probably the right answer, right? I mean, when you only have one dose, I guess you can't, it's hard to model.
Well, Professor Haber, who's written the seminal paper on benchmark dose, will respond, I think. I'm going to step
Okay, that's good.
Go ahead, Dr. Haber.
Lynn Haber, SACC. Thanks for the plug, Dr. Dorson. So I think why they were not modeled, of course, is a question for EPA, who made that decision. I think you might be able to get decent fit, but I think the other consideration was probably that just by eyeballing the data, that's clearly a less sensitive tumor type than the liver tumors. So if you're looking at the most sensitive tumor type to determine a unit risk, then that would be a reason for focusing on the liver.
Thank you. That's that's good. I didn't mean to cause trouble.
Thanks for that good discussion. Now we'll go to EPA to see if they have any clarifying questions.
You can go to the rest of the
Oh, I'm sorry. You're right. Thank you. I'm sorry, I got stopped. So wait, I need to go to the rest of the committee, right? Is
Yes.
that what's next?
Yeah,
Or-
that's
I'm
what's
sorry.
next.
Well, no, I also
Okay.
haven't directly responded to the general question.
Oh, okay. Go ahead, Dr. Haber. I'm sorry.
Lynn Haber, SACC. That said, I don't have a lot to add, but I did also just want to underline what Dr. Lowe had said earlier, that if the committee does end up, or if EPA does end up with a suggestive evidence of carcinogenicity, then generally no dose response assessment is done. So a lot of this discussion about benchmark dose goes away for this chemical, although of course the whole transparency issue is important in general.
Good point. Anybody else from the rest of the committee have anything else to add on 9C? Not seeing anything. I'll go to EPA, and I guess we will be revisiting 9C also later in the week. Any clarifying questions from EPA?
I think, Ms. Gentry, you just answered that question about whether or not we will be circling back. So I guess the answer is yes, you are going to circle back. So maybe I'll hold my clarification question, but I was, if you wouldn't mind, going to ask Dr. Thompson to reread quickly, not too quickly, so we can hear it better. I think it was the first two recommendations. The first one, I believe we're hearing a recommendation to look more deeply at the mode of action data and see if a mode of action can be put together, or at least a hypothesized one. But then the recommendation after that, we're not 100% clear on if at least the working or the current draft, or I'm not sure how to describe it, recommendation is to do nonlinear given the results of the mutagenicity data, and along with a number of other points that you made. Maybe you can clarify those 2 points for us, or maybe you hold in clarifying those since you're still deliberating.
Yeah, let us include that in circling back, if you don't mind.
Sounds good. Thanks.
Great. Thank you. Okay, now we're going to move to ethylene dibromide, and we're going to go to charge question 21. So if EPA could put charge question 21 on the screen and give folks a couple of minutes to read through that one before reading the charge. Actually, this is a really long question, so go ahead and start reading to yourselves.
Okay, I'll read the charge question. Johnny Corrales, EPA. Given the paucity of avian hazard studies on ethylene dibromide, please comment on the appropriateness, including strengths and uncertainties, of the use of the STIR model to derive an acute inhalation hazard value for purposes of risk characterization of avian taxa. include in your response comments on the strengths and uncertainties of the empirical data used to derive the LD50 for Japanese quail and the strength of the data to support a quantitative risk assessment.
Thank you for reading that into the record. And we're going to go to our lead discussant for charge question 21, and that's Mr. Greg Garvey. Go ahead.
Hello, it's Greg Garvey from the SACC for charge question 21. EPA has requested the committee review their use of the screening tool for inhalation risk, otherwise known as STIR, S-T-I-R, for modeling inhalation hazards to avian taxa from potential ethylene dibromide exposures in ambient air. In the draft assessment, EPA utilized the STIR model to extrapolate acute oral avian toxicity data as LD50 data, or lethal dose 50, to an acute inhalation dose, extrapolating these differences by utilizing oral and inhalation toxicity data for mammalian species, laboratory rats, for ethylene dibromide and allometric scaling. This approach was used as no acute or chronic inhalation toxicity data are available for ethylene dibromide in avian receptors. As ethylene dibromide is not considered to be bioaccumulative, the draft assessment did not consider oral exposures, stating EPA conducted a quantitative assessment of ethylene dibromide in ambient air using the STIR model. As part of its review and in response to EPA's request, the committee has reviewed the STIR model, including the intended use of the STIR model and the appropriateness of utilizing the model for TSCA risk assessments, as well as the specific model inputs provided in the draft assessment. As captured in Table 310 of the draft assessment for ethylene dibromide, laboratory studies in birds have demonstrated that there are some adverse effects related to chronic dietary administration of ethylene dibromide. These studies indicate that ethylene dibromide has potential adverse effects from oral exposure, and it does demonstrate the potential for adverse effects from sufficient exposure from inhalation. As such, the committee does recognize that it is critical to use a method such as STIR to estimate potential hazards and risk to avian species. However, the committee does note the literature are very dated, and more current data on avian responses to environmental contaminants, especially those similar to ethylene dibromide, are necessary. Overall, the approach of using the STIR model appears simple and explicit as a screening tool in the problem formulation phase for inhalation risk to avian receptors. It is stated to be a tool that will be used to determine if further data analysis is necessary, which does seem appropriate for the draft risk assessment. However, the model does have a number of assumptions limitations that would suggest a need for further data analysis or avian inhalation studies. Excuse me. Despite these strengths and the need for something like the STIR model, the committee recognizes there's considerable uncertainty due to the limitations and assumptions that the STIR model uses. The largest uncertainty is the lack of direct avian inhalation toxicity. The STIR-derived avian inhalation LD50 is based on a number of key assumptions. The first being that root-to-root extrapolation from oral to inhalation pathways. The STIR model assumes oral toxicity data can be used to predict inhalation toxicity data. However, the committee understands and recognizes that differences in absorption, metabolism, and target organ delivery between these exposure routes may affect toxicity. In addition, the STIR model uses mammalian to avian extrapolation. And although similar rat and quail oral LD50 values support this approach, there are physiological and metabolic differences between birds and mammals that represent a significant source of uncertainty. Ethylene dibromide is metabolized through cytochrome P450 oxidation and glutathione conjugation pathways. Species-specific differences in metabolic pathways may influence toxicity. Birds, for example, have air sacs as part of their respiratory system to optimize uptake of oxygen for flight. But other gaseous compounds can also be taken up and enhance exposure. Japanese quail, excuse me 1 second, used in the study are precocial birds, which are independent and mobile at hatch with minimal parental care for protection. Whereas many birds are altricial, songbirds, raptors, and some seabirds that are dependent on parental feeding and care. Accordingly, these nestlings will have chronic exposures to environmental contaminants, particularly in nests close to a source of ethylene dibromide, where precocial chicks will encounter contaminants that are persistent in seeds and other environments. Because of these, mammals and birds are not directly comparable in many of these physiological responses. Also, birds may have higher body temperatures, for example, 105 degrees Fahrenheit, internal testes, and higher metabolic rates. In addition, STIR assumes allometric scaling for respiratory physiology, and it assumes body mass scaling adequately captures the interspecies differences in respiratory function. However, the unique avian respiratory system may result in inhalation uptake rates that differ from those of mammals. Comparable toxicokinetics across taxa. The model assumes similar absorption, distribution, metabolism, and elimination processes across these species. However, different avian taxis, for example, ground-feeding birds, raptors, passerines, and migratory species, may exhibit different toxicokinetic and toxicodynamic responses. The committee also evaluated mortality as an endpoint of concern, and while this is a robust objective endpoint, it may not be the most sensitive measure of ethylene dibromide toxicity. Sublethal, reproductive, developmental, neurologic, or behavioral effects could also occur at lower exposures. Let's see, use of a derived, sorry, my mouse is acting crazy. They used a derived rather than a measured rat inhalation LC50. The rat inhalation LC50 was derived from mortality observations rather than obtained from a directly reported LC50 study. Uncertainty associated with the derivation of the rat inhalation LC50 propagates directly through the STIR model and affects confidence in the resulting avian inhalation LD50 estimate. While these assumptions are scientifically reasonable for a screening level assessment, each of these contributes uncertainty and should be considered when interpreting the resulting avian inhalation hazard value. The first step was reviewing the STIR model. And so the first thing we did was the committee reviewed the STIR version 1.0 User's Guide for Pesticide Inhalation Risk from 2010. This review identified a number of concerns with the STIR model in relation to the intended use of the model and its use in the draft assessment. Excuse me. It's a long one. For example, under the section When to Use This Model, this indicates that the model will, quote, be used as a screening tool in the problem formulation phase, end quote, of risk assessments, and, quote, will not be used to either quantitatively or qualitatively determine risk. Rather, the tool will be used to determine further data analysis are necessary for inhalation risks. The EPA science who created this model understood that these limitations, such as lack of inhalation toxicity data, would preclude this model from providing quantitative estimates of risk, but provides rather a yes or no if further evaluation of the inhalation pathway is necessary. Further in the guidance, in the section Follow-up Action Based on Model Results, EPA states, the results of the STIR model do not definitively assess risk from inhalation, but rather provides a screening level evaluation of the need for more information to better characterize inhalation risk. Excuse me. The committee ran the STIR model using the inputs provided by EPA with the estimated adjusted inhalation LD50 value, and while this was consistent with the draft assessment, the model output indicated, quote unquote, proceed to refinements based on the ratio of the unadjusted inhalation LD50 that was greater than 1,000. When the model flags proceed to refinements, the STIR guidance suggests the user should request an inhalation study if the model output recommends proceeding to refinements. In addition, the model output also indicated that the inhalation exposure for avian species is, quote, not likely significant for ethylene dibromide when used as a spray in air. The committee is concerned that the exposures outlined in the draft assessment, such as refueling a jet engine, would not result in the presence of birds or potentially significant exposure given the volatility of ethylene dibromide and the deterrent present of airfields for birds. This is supported also by a lack of published reports of anecdotal evidence of adverse effects of avian receptors throughout the use of ethylene dibromide as a commercially applied fumigant. These two flags in the model indicate that perhaps the use of the STIR model in place of empirical data may be premature until further toxicity tests or refinements to the model inputs become available. This model does have strengths. However, the committee does agree that the model is relevant to the primary exposure for ethylene dibromide as it is highly volatile, persistent in air, has long-range atmospheric transport potential, and exhibits low bioaccumulation potential. Consequently, inhalation is expected to be the dominant route of exposure for terrestrial wildlife, making an inhalation-based hazard assessment scientifically appropriate. One committee member did conclude that the model integrates multiple lines of evidence, such as rat inhalation toxicity and rat and avian oral toxicity data, to provide a biologically informed linkage between exposure route and species sensitivity. Getting to more of the STIR model uncertainties, I think we've discussed some of these. So, let's see. Both the model and the draft assessment provide a discussion on the uncertainties. However, some of these uncertainties, one committee concluded that the availability of acute toxicity data only for rat oral and inhalation and Japanese quail oral exposures makes the comparable physiological responses difficult. The model incorporates empirical toxicity data from both mammals and birds, relying solely on theoretical predictions or structure-activity relationships. In terms of the assumptions being able to convert mammalian inhalation acute toxicity data to avian acute inhalation toxicity data, the vascularization of avian lungs may differ from mammalian lungs and influence diffusion rates. The differences in enzymatic activity in lungs may also affect rates of chemical formation. One committee member did comment that there may be some biological plausibility because the rat oral LD50 of 124.2 milligrams per kilogram body weight and that of the Japanese quail, 130 milligrams per kilogram body weight, were similar, thereby providing some empirical evidence and support for the biological plausibility of mammalian to avian extrapolation. While another committee member considered this possibility to be coincidental and without further data points was not a useful comparison. These root-to-root extrapolations are also highlighted in some of the studies that EPA cites in the draft assessment. In Westlake et al. 1981, in tables 1 and 2, the study authors provide measured parameters to a dose of 65 milligrams per kilogram body weight to the Japanese quail via two exposure pathways, oral gavage and intraperitoneal injection. The data in these tables identify a number of parameters that, while statistically significant for some, had other endpoints that were not statistically significant and therefore were different. For example, body weight, glucose, total protein, aspartate aminotransferase, sorbitol dehydrogenase, plasma total lipids, and hemoglobin. These inconsistencies in effects at the same dose indicate that exposure route does play an important role in the significance of an adverse effect. Let me see. We talked about that one. Lack of chronic toxicity data. One member did support the use of mortality as a robust endpoint, while another committee member concluded that lack of chronic data for assessing the effects of ethylene dibromide may underestimate effects at the population level, given that acute endpoints are not as sensitive in capturing the lower concentration effects of chronic endpoints such as growth and reproduction. Let's see. We did discuss the avian conversion. There was some concern about the model assuming a single temperature, and I know we did discuss this a little bit, but one of the concerns was that because the metabolic rates increase with temperature, particularly with animals with smaller body sizes with higher metabolic rates, that these basal metabolic rates of birds have been shown to decrease with increased body size, and passerine birds can range below the modeled avian weight. Moreover, these relationships may not be linear. Inhalation doses of droplets or vapor in the model are dependent on avian body weight and likely increase if body weights that were entered were lower. Let me see, it's the body weight. In addition, the model assumes birds are non-passerine species when passerine birds make up more than half of all birds. Moreover, passerine birds are known to have higher oxygen consumption per body weight than placental mammals, as well as higher basal metabolic rates than non-passerine birds of the same body size. So the model should take into account other types of birds other than the ones used in the assessment. In addition, okay, so in one revision to the HED calculation, in section 3.3.1.2.4, avian hazard thresholds, the committee has reviewed equation 3.1 and recommends that EPA review the exposure duration. In the draft assessment, the exposure duration in hours is 8,760 hours, which is calculated as a continuous exposure for 1 year, 365 days times 24 hours a day. However, the HED provided in that equation is for acute exposures only, as there are no chronic studies for avian exposures, and the toxicity value from the STIR model was an acute LD50 value. In addition, the STIR model guidance indicates that the HED from acute LD50 value is the duration of vapor inhalation is assumed to be 1 hour. The committee questions whether a shorter exposure duration of 1 or 24 hours is more appropriate for the HED calculation, given the short-term nature of the toxicity data, the intended use of the STIR model, and the identification of STIR to derive a quote-unquote acute inhalation hazard value as identified in the charge question. This is further supported by the HED units provided in the draft assessments in milligrams per kilogram body weight, indicating a one-time internal dose, not a daily exposure, which would be in milligrams per kilogram body weight per day. We've got the respiration rate. So moving on to the overall recommendations. For the overall use of the STIR model, the committee has a consensus recommendation that EPA should revise the evaluation of this pathway, either with the STIR model, with modifications, or another model that incorporates the unique characteristics of birds, including metabolic rates, proximity of sources of potential exposures, especially for nestlings, and life stage differences in sensitivity. The committee also recommends incorporating current measures for adverse effects in birds that include physiological indicators of acute and chronic exposures that go beyond mortality that must be part of any model developed for wildlife, and in particular avian species. This consensus recommendation was based on a number of things. One committee did recommend that the EPA reevaluate the use of the STIR model completely at this time. This committee member felt that based on EPA's original intended use of the model as a screening tool, not for criteria development, and the uncertainties associated with the extrapolation of mammalian toxicity data to avian inhalation data makes the model inappropriate for use. Let's see. While another committee member did determine that the STIR model is scientifically reasonable given the limited availability of species-specific avian inhalation toxicity data for ethylene dibromide. This committee member felt the approach is consistent with established ecological risk assessment practices that use cross-species extrapolation and allometric relationships when empirical inhalation studies are unavailable. The committee recognizes that the most defense and protective approach would be for assessing potential inhalation effects would be to conduct chemical-specific avian inhalation studies, such as the STIR model indicates, using chronic exposures of small-bodied avian receptors over a range of temperatures. However, the committee does recognize that EPA does have limitations and timelines for this assessment. And absent this empirical approach, it would be worthwhile to run the model with a higher range of temperatures using a broader range of avian body weights that would capture smaller passerine and non-passerine species, or consider including NAMs such as Rheticross if available. Let's see, getting to more specific recommendations on page 173 of 349, line 5759, EPA states the weight of scientific evidence suggests that ethylene dibromide poses acute inhalation hazard to terrestrial birds at a hazard threshold of 2 micrograms per cubic meter. The committee does request EPA reconsider if the weight of evidence provided in the draft assessment suggests such a strong statement about ethylene dibromide toxicity to birds, given the model uncertainties and the lack of avian inhalation toxicity data. The committee suggests altering the statement to indicate that the weight of evidence indicates some toxicity may occur, but is inconclusive to accurately predict an avian-specific concentration. Another recommendation in equation 3.1 for deriving an avian air concentration for ethylene dibromide, the HED and HEC abbreviations are used, but are not correctly or adequately defined. In the glossary, these are defined as human equivalent dose for HED and human equivalent concentration for HEC. The committee requests EPA revise these abbreviations in equation 3.1 to indicate that these are avian equivalent doses and concentrations using AED or AEC if those if those abbreviations are available, or cite the publication where the equation originates with an explanation of why an HEC, HED is appropriate for assessing avian hazards. In addition, in section 3.3, what's this thing doing? 3.3.1.2.2, inhalation exposure, page 172, line 5647, EPA states that the LD50 derivation for avian species is available in Appendix G. Appendix G is the mammalian LD50 derivation, and Appendix H is for avian species. The committee recommends EPA fixing this in the document. I believe those two are it. We've covered the other two.
Does that complete your
That's
summary?
it, yes.
Thank you. That's a lot. Okay, I'm going to move to the associate discussants, starting with Dr. Chen, to see if you have anything else to add for question 21.
Wow, great job, Mr. Garvey.
Yeah.
No, I think he covered everything, and I'm really appreciative that he pulled that all together for us. Thank you.
Dr. Tansel, anything else to add?
Yes. Wow. Wonderful summary. We have had 2 meetings as a subgroup, and great job. Yeah, my comments were addressed.
Thank you, Dr. Lee. Anything
Wonderful
else to add?
job. So I don't have any additional like technical comments for now, but I want to emphasize another thing, not only for this question, this specific STIR model. So I think in many cases, especially in the case of data lacking or data poor chemical situations, EPA had no choice but to use some screen level models, just like the STIR model in this case. Of course, we also have other screen level models in fate and transport, bioaccumulation, and other toxicity simulation. So my overall recommendation is EPA should make it clear in the report that these results are just a screen level. and not treat them as the final conclusion. And if EPA does find a concern for some chemical, EPA should indicate that this is something concerning and they should trigger higher level, higher tier of assessment. But if EPA doesn't find any concern for this chemical, EPA should also highlight this is just a screen level and should not just stop there. And more importantly, they should not indicate that the chemical is safe for now. Yeah, that's my additional comments, not a technical one related to this one.
Thank you for that comment, Dr. Lee. Dr. Baker, do you have anything else to add?
Nope, with nothing for me, thanks to Greg. That was awesome.
Thank you. Is Dr. Ottinger on the call? I don't think so. She was the other associate discussant on this question, but she did submit comments to the lead discussant for this. And now I'm going to open up to the rest of the committee if they had any other comments on charge question 21. Anybody else? I'm not seeing any, so I'm going to go to EPA now to make sure that the recommendations that the charge question group came up with, the recommendations are clear. If you have any other questions or clarifying questions about that.
Donna Corrales, EPA. At this time, EPA does not have any clarifying questions. Thank you.
Okay. Now I think I'm going to I am going to turn it over to Dr. Gentry because we are going to, does somebody else have anything else? EPA, do you have anything else? No. I'm going to turn it over to Dr. Gentry, who's going to talk about what we're going to do for the rest of the afternoon. Thank you so much.
Thank you, Ms. Jenkins. We are getting quite a bit ahead of schedule, and as you've noticed, we've had to move some things around. And so what we're going to do is adjourn early today and give our discussant groups some time to make sure recommendations are ready to be presented as final, whether they be majority, minority. So we won't have to continue revisiting questions this week. So the plan is to start tomorrow morning with charge question 10 and move through the remainder of the charge questions we haven't discussed yet. And then after that, beginning revisiting. I'll turn it over to Ms. Munir in just a minute to adjourn us for the day, but I would request that all the committee members stay on the line for a brief meeting. You're on mute.
Just fix. Yeah, what about now?
Now, I heard you.
Great. So, okay, great. I'm glad. So again, thank you, Dr. Gentry, and thank you, Ms. Jenkins, for running through day 2 of this peer review. I want to also thank the EPA Program Office for their responses and for participating today, and also, lastly, but certainly not least, the committee for your active participation, deliberations, and discussions on the charge questions and the responses. With that said, thank you very much. Have a good rest of the afternoon, and this meeting is adjourned. Thank you. And committee members,